it's just an audio check. Yeah, because I could pull it over, but I'm not sure. Like, we didn't get a check, so I didn't even mess up the file. So basically, I'll introduce Dan, and then we've got this placeholder. I wrote down what you're supposed to introduce Linda, and then you would just go to this file. That would still be open there.
I introduced her while this one's up.
Or you could go straight to this one.
Okay.
And then after she's done, it's the break, right?
No, after she's done, then it's the panel.
The panel, then you just go back to the, this is just the same standard.
Okay, and I just go to the next.
Yeah. And I said,
Or is
thank
that
Linda,
same?
introduce Bernice to the book account. It's the same thing for them. I just changed the notes for you. If
Okay.
we need. I was originally going to pull her slides like in between there.
Yeah.
But
Okay. So I'll just exit out of the.
I could still try to do it. I just don't know if she has videos or anything. Do you know if she has video? She has slides. Okay. So I'll just copy all those and paste it here. Yeah, it's gonna mess up the. I can do paste. Source formatting. Okay. That looks like maybe some of the font stuff or. Which one is that? Something green. This one? Yeah, I think it looks better on hers. If you want, while you're introducing her, I could go here and like swap it.
If I look like I'm struggling, come on up.
Okay.
I was trying to just do short introductions, just
Yeah.
timing, so I wasn't going to say a whole lot about her. Yeah.
Sure. Want to put an amendment? I mean,
Yeah, maybe we could probably use a couple more minutes just to make sure.
It's 9:05, so.
Yeah.
We want you to be comfortable, John.
Yeah. Okay. So I'm just going to say like 3 sentences, and then I'm going to turn it over to you.
Okay. And you were going to mention the trainings. Thanks for everyone who came
Oh,
to the
okay.
2 trainings
I did
and the
not know you
fireside
had
chat.
You never told me what you wanted me to mention.
If Michaela's not in the room, then I guess you shouldn't point her out. But I guess you could say that she'll be available. Are there any questions about local stuff?
Okay.
You could tell people about the Wi-Fi, or if it's, well, I think everyone knows already. Let me grab my post-it with Dan's bio.
Yeah, I have mine are kind of interspersed in here. larger font. I'm sure it was. Yeah. Are these live? Oh, I mean, are we mic'd? Okay. Okay. Ready? All right.
Sound check. John, are we okay to live stream?
Is this mic on? Oh, okay. We're going to go ahead and get started. Thank you all for joining us today. I want to welcome you on behalf of the University of Washington and the eScience Institute to the launch event here in Seattle for the National Transportation Data Challenge. My name is Sarah Stone. I met many of you last night at our reception in the eScience Institute, and I know many of you participated yesterday in the tutorials and trainings on Azure and AWS. So we welcome you to the Seattle area, and thank you for joining us for this event. My name is Sarah Stone. I'm the co-executive director for the eScience Institute and also a deputy director for the West Big Data Innovation Hub. And I'm really excited with our lineup of talks, panels, and activities for today that highlight innovations in transportation data activities. Without further ado, I'd like to welcome the West Big Data Hub Executive Director, Meredith Lee. She's going to talk about the Big Data Hubs and introduce you to this challenge.
Thanks, Sarah. Can you hear me okay in the back? Great. Welcome to Seattle, and welcome for the folks tuning in by live stream. On behalf of all of the executive directors from the 4 regional hubs, I'm really excited to be here, and thank you for taking the time out of your day to participate in this and for the outpouring of enthusiasm that we've seen. As Sarah mentioned, people were at the reception last night. It was supposed to go from 4:30 to 6. People were still there 7:30, 8 o'clock, having wonderful conversations and sparking a lot of collaboration. So we were really excited to see that. At the fireside chat last night, I met people from Colorado, Idaho, Nevada, Wyoming, Illinois. There's probably more states represented, so we're really excited to have you joining us. South Carolina, someone flew all the way from South Carolina. That geographic diversity and the similar diversity that we're seeing in expertise and interests in the room is really present in our Challenge Advisory Board as well. So there's a whole slew of tireless and creative organizers who you'll get to meet today and work with throughout the afternoon. And hopefully you like them because you'll be working with them for about 4 months if you're signing up for this challenge. I think they're fantastic. If you guys could stand up in the room and just let people know who you are. Eddie from all the way from Washington, D.C., representing the Department of Homeland Security as the AAAS Science and Technology Policy Fellow. We have Nick Bagley from Utah, representing the nonprofit space, and he's also on our steering committee for the West Hub. Dave Goodsmith from Data Science, Inc., representing the startup and medium-sized business community, also leads our Metro Data Science Working Group. And Jane Zanzig from University of Chicago, also representing academia and the nonprofit space through Data Science for Social Good. There's a number of hub leadership folks who weren't able to make it but are tuning in by live stream, so hi folks. People from Nebraska, Michigan, Georgia, North Carolina, and a shout out to New York City. We'll get some of those collaborators via video later today. So in case you haven't noticed, this isn't your typical hackathon or your typical workshop. We've tried to be much more strategic and intentional about curating all of the exciting, great projects that are existing right now, the data, the mentors that are available, and building upon those. When we were discussing, when Dan Morgan, Chief Data Officer of DOT, who you'll meet shortly, was discussing this with all of the executive directors of the hubs, we thought about how we might best identify gaps, discuss the project ideas with different stakeholders, including the end users and your fellow participants in this challenge, and finding a way that we could incorporate feedback so we're not trying to solve problems in a vacuum. It really boils down to smarter project design and project management and looking at the whole ecosystem. And we saw a lot of those themes yesterday throughout the fireside chat with PNNL and with Dan. Our hypothesis is this, that building and strengthening the connective tissue between you all and facilitating this physical space and the virtual space for all the folks joining remotely will allow us to exchange ideas, run experiments, and share lessons learned and best practices across different groups, whether you're in industry, academia, nonprofits, or government at any level. And we'll end up, hopefully, with more compelling results that really leverage the different ways where we can each contribute. So this type of building and strengthening connective tissue across all those different sectors is really what the Big Data Hubs do. We don't have a lot of time. You'll see there's a packed schedule with probably 14 different lightning talks later today. So I'll point you to our different websites to learn more about the different thematic areas, whether it's medicine or metro data science or energy and environment. But today, being gathered here for transportation science, it's really because in our first 1.5 years since getting seed funded from the National Science Foundation, we found that metro data science, and particularly transportation, is an area that's really ripe for collaboration across those different sectors. There's a lot of exciting movement in this area, great work already going on that we could leverage. So again, welcome to this series of community problem-solving sessions, of community data fairs, hackathons, and demos. We hope you'll share your ideas and your skills, meet new teammates, and work across state borders. It's very community-driven, so we'd love to have your input throughout the day on metrics of success, what could be possible when we bring all of these excited folks into the same room, in the same virtual room. And we're really super excited to get started on this adventure. And in terms of going on adventures, I don't think there's anyone we'd rather go on an adventure with than the Chief Data Officer of the U.S. Department of Transportation, who happens to be here. I think this is his first time to Seattle in about a decade or so we're excited to welcome him. Dan Morgan has been the CDO of the U.S. Department of Transportation since August 2014, so he's coming up on his 3-year anniversary. He is now also, as of a couple of weeks ago, acting Chief Technology Officer. And Dan and I met way back in DC when he was hosting a Safety Data Palooza, and then we ended up co-hosting multiple Safety Data Paloozas over the years, and it is as fun as it sounds. He has a background in mechanical engineering and did many years of consulting with the Navy, and is a Chicago kid. So without further ado, please help me welcome Dan Morgan to the stage.
All right. Good morning. You can say good morning back. It's okay. It's early, I know. It's like afternoon in the rest of the country, but it's early here. So as Meredith said, I'm very excited to have this collaboration amongst the big data community and some of the transportation community on this very important topic of transportation safety. It's exciting because I think we have some really new opportunities to use new data sources, to find new data sources, and help decision makers on a variety of time horizons make interventions that can make our communities safer. Now, that's a really general statement, so I'm going to try to make it a little more precise and real as I go through this talk. But one thing that is important to think through is transportation is a leading cause of death in this country. That means that heart failure, cancer, and all these other kinds of things, transportation is a big killer. And we have to pay attention to it, not just in the transportation world, but in the public health world, in the transportation planning world, in the way we build place, and the way we engage communities. Every day, we lose 100 lives on our roads. That's as many people as we lose to gun violence. There's a national conversation about one of those things, not both of those things. We have an opportunity to bring our skills to bear to start to raise awareness and activate a community around this problem. The big data opportunity in transportation and in safety science really is sort of threefold. There's the human factors bit, right? So 94% of fatal crashes are in some way related to human error, right? So we've got connected vehicles and automated vehicles and these new technological developments that will take some time to actually reach critical mass as they mature. But we can't wait for all of that technology to come online and continue to lose lives on our roads. So there's a big data opportunity there, and it'll be important from the operator of a conveyance to be able to make a safety decision or to have active safety systems to help keep them from getting in a crash, and that's an important piece, and we should continue to do that work. But there are decisions that we can make today, data we can use today to reduce the risk in the transportation system. There are environmental factors that we should consider. Transportation is an inherently economic activity, right? So looking at census data, unemployment data, the way we build place, the way we use land, and the types of roads that we build around those places. The paint on the road is the operating system of the road. If we change the paint, we can change the risk profile of the road. It's a low-cost intervention with a big return for safety and for the creation of place. What are the kinds of decision products that we need to be able to give to our communities, to our transportation planners, and to our leaders so that they can make smart investment decisions with their limited resources for the biggest impact? There's plenty of vehicle safety work as well. And I think we've seen in the data, and I'll talk a little bit about this a little bit later, but we've seen in the data that the people inside the vehicle are generally increasingly safer. When I go through the trends in a little bit, we'll talk about it. But the top line is non-occupants make up a greater share of our total fatality number than vehicle occupants. So 10 years ago, about a quarter of the roadway fatalities were people who were outside the vehicle, pedestrians, bicyclists, other sort of bystanders that might be by a road. Lately, it's more like 35% of the total fatality number. So while we may be improving the individual vehicle safety, there's still an environmental factor here that is sort of persistent. The total number of non-occupants that are killed every year is pretty much constant. It varies by a couple hundred, but we're not making great progress on this. So thinking through some of these persistent problems means that we're not going to solve it in a weekend or in a day of hackathon, right? But bringing together a variety of disciplines to address the kinds of decisions that we need to make and the various decision horizons that there are in the transportation system, the interventions that are available to us or that could be available to us if we had better data, and addressing some persistent data gaps can be the opportunity that comes out of this data challenge. And I'm excited to see all of you involved in it. So when we're looking at the topics that you all are addressing as part of the Transportation Data Challenge, bicyclists and pedestrians. I have good data about the total number of bicyclists and pedestrians that were killed every year. I don't know how much walking or biking there is. I don't have, I could calculate how many vehicle miles people drive every year. And we have methodologies for that. We have methodologies for counting pedestrians. It turns out it's really hard to observe how much walking and biking occurs. And so we can't calculate the number of fatalities divided by the number of miles walked. There's an opportunity to use big data techniques to try to get us better data about how much activity might be going on, right? We've talked about, you'll hear later today about some things that are happening here in the Seattle area to try to use video analytics to get better counts of pedestrian activity. And that's a good thing. I think there are other opportunities to try to observe that activity using fitness trackers and finding ways for people to be able to donate their data in those kinds of regards. But those are going to create new modeling challenges, new selection bias challenges, and other kinds of things that we're going to need to address in order to help our decision makers understand what's happening on our streets. When I was telling my mother about all of the news around the increase in fatalities, she said, distraction is a huge problem. And I think, how many of you think distraction is a really huge problem and it's getting worse? Yeah, probably, right? We don't have any data about distraction. It turns out it's really creepy to measure distraction if you're the government. So, and so we don't necessarily have tools to work together with academia and the private sector today that can help us understand how much distraction there has been and whether distraction patterns are changing. And so this is yet another opportunity as part of this transportation data challenge to close that data gap and figure out different ways that we might be able to measure distraction. Direct observation is really difficult. And understanding when that distraction occurred, the extent of that distraction, when you're moving at 35 miles an hour, 50 miles an hour, or 70 miles an hour, it doesn't take much to make that mistake. It's a very situational kind of data point that turns into something very awful very quickly. Being able to measure these kinds of changes is a big deal. You guys are also talking as part of this transportation challenge about weather and emergency response. So you'll see some of the cool things that we're doing in terms of connected vehicles and trying to have communications amongst trucks in Wyoming as they move through mountain passes, because the weather is very dynamic and the environment is very dynamic. And those are good situational awareness things. But remember that there's somewhere distant from that highway or somewhere in that city, traffic operations center or traffic management center, where there are humans looking at a wall of screens. And on their desk is 4 or 5 monitors stacked, and they're monitoring Twitter and police dispatch and Google Maps and Waze and every other data source one at a time. There's no integrated view to help them figure out where to send a help truck, whether or not to send snowplows, and other kinds of treatments that could keep the road safe. Don't just think about the vehicle operator. There are city and state operators who also need big data products to help them operate the system more effectively, allocate their resources more effectively. Salt is very expensive, right? And so we're always looking for ways to shave cost off of salt and other kinds of treatments, figuring out how we can build data products to help those operators build their plans, allocate their resources, and respond to incidents on the road more effectively is going to be a big piece of this as well. Franz is here. He's a planner. Planners work on a totally different time horizon than the few seconds that you have while you're operating a road, or that day or that minute or that hour where you're trying to figure out where to send help trucks. They're thinking big. They're thinking far in the future. It's very difficult to predict the future in transportation, believe it or not. And so planners work really hard on data integration problems. And I think you'll find that being able to understand some weather impacts makes it easier for us to understand whether we can make small treatments to a road that maybe reduce its sort of vulnerability to flooding, or other kinds of choices that will help us make that roadway safer. And those are longer-term engineering projects that get planned that end up trying to make that road safer. So those are 1-year, 5-year, 20-year, 30-year horizon kinds of decisions that we need to be able to make to build a system that's resilient. You'll talk a little bit about automated vehicles, and we can talk about that all day, I think. I think my big point on automated vehicles is, yes, there are huge big data opportunities, and there are important things that we can do to feed video and other kinds of things to help those automated vehicles understand a wide range of scenarios that they can train with in simulation. But there are real things that we can work on today while we work on the automated vehicles revolution. So we need to have our foot firmly planted in the present as well as our eye trained on the future. And I think that's really important as we try to understand what that big data opportunity looks like. So with that, I'll give you some pictures and facts about roadway fatalities. This is an average year of roadway fatalities. Across the top is a month, and across the vertical axis is the day of the month. So this is one way that we can try to look at whether there's any seasonality or cyclical nature of some of these transportation issues. You'll notice there's not really a whole lot of pattern on just vehicles that are driving around. But patterns start to emerge when you look at things like pedestrians. And it's in the winter months where pedestrian fatalities tend to get a little more intense. Can anybody offer a reason why in the room? I know there's a bunch of people on the live stream. It gets dark. It gets dark earlier, right? So the number of daylight hours is reduced in the wintertime, and it becomes more difficult to discern a pedestrian. So that is something that we can work on. It turns out that we need to understand how people perceive the built environment. The treatment might not be more alerts on a car. It might be lights. There are lots of countermeasures that are available to treat a condition like lighting or speeding or those kinds of things, and thinking through what that might look like as we try to feed a decision maker is I think where we need to build those bridges amongst the big data folks who are trying to understand the wide range of features and the people who are using the transportation system and the transportation folks who are well trained in the engineering piece, right? And as we build those bridges for the engineering decision maker and for the planner and for the transportation operator, understanding what their information needs look like will help the big data community find the right data sources and decision products that will make us more successful as we try to address this problem. The other thing I'll say is, if we start to look at bicycle fatalities, I know 800 people a year is a lot, right? It's more than zero, so it's unacceptable. But this is a very sparse number when you start to plot it, right? As much as I can tell you that 35,000 people is a lot of people, and we should be working really hard to reduce the number of people who are dying on our roads, that sample size is very small. The number of crashes that result in an injury, that means somebody from an emergency medical services is going to respond to that scene and either treat at the scene or take people to an emergency room. There's about 3 million of those a year. If you go to property damage only crashes that are reported to the police, there's about 6 million of those a year. That includes the injury crashes as well. And then there's not police reported crashes. There's another 6 million of those on top of that. So you're looking at a universe of things hitting things and having different outcomes of about 13 million crashes a year. Very few of them result in a fatality. And yet, I think we need to be able to gather that data, collect that data from the federal level, the state level, and the local level, and start to combine it into new decision products. One of the challenges that we're going to have as you guys progress through the National Transportation Data Challenge is not only sort of building context around a set of transportation data about fatalities, infrastructure, investments, and those kinds of things, but building depth and texture to that data as well by going and grabbing state and local data that's authoritative and very difficult to combine. Because at least when I do the census of fatal crashes at the federal level, I get those variables to be consistent. When you start grabbing state, local, open data, it doesn't always follow a standard, right? Standards are like toothbrushes. Everybody needs one, but nobody wants to use anybody else's, right? So being able to combine this data and make sense of it and understand what changes in reporting thresholds are or what collection rules are and those kinds of things, I think is going to be a challenge as we move ahead, but it's necessary because you can't make national prioritization decisions off of just the fatality number anymore. It's getting smaller, and we need to bring that full texture back to the picture. This is that same kind of chart, only this is day of week and hour of day. So I guess when everybody's groggy in the morning, it's less bad. But when you're looking at the afternoon for a motor vehicle and transport, things get a little bit more intense in terms of when fatalities are occurring. Pedestrian fatalities get concentrated at night and on the weekends. There's lots of reasons that could be. But this might point to how we build place, right? And what kinds of treatments we put on a road as we decide how we're going to build place. Proximity to entertainment, for lack of a better term, can create dangerous conditions, right? And understanding what that might look like and how we might build differently, zone differently, or treat roads differently if we're going to build a place that has lots of options for late night activity and pedestrian access and potentially intoxicated folks on either side of the road. Understanding how we might treat that and design that space better so it's less risky, I think will be a key as we move ahead. There's still a visibility problem. Now, I've seen a lot of different approaches around visibility, but thinking smartly about how to address these visibility issues as we get to dusk and dark, I think is also going to be key. So understanding that it's not always about putting a more powerful headlight or another beep on a car, but how we build space is essential. And building that bridge to not just transportation planners, but landscape architects, the people who design our cities, is also going to be key because they understand human behavior. And building all of this into a big data decision-making process can be challenging, right? I haven't talked a lot about like high volume data or fast-moving data at all. I've talked about complex data. When I start pouring transportation information, infrastructure information, census information, unemployment information, human choice information, all this kind of stuff into one great big data soup, I've got a ton of features that I need to start working through in order to figure out whether these models are telling me anything meaningful. That is the core of the big data challenge in transportation. It's that mix of how humans interact with environments that is one of the hardest things to solve. I get asked this question a little bit. We've made incredible progress on roadway fatalities over the years. We've been tracking this number since the 70s. And when we started, it was about 50,000 a year, and we made huge progress over the years. In the early 2000s, like 2000 to 2006, we were looking at about 42,500 fatalities a year. And there was this period of slow decline, and then we got down to about 33,000 a year in 2009, and there it stuck for a little bit. And then 2015 came around, and we're back at 35,092 lives lost. Our estimate for 2016 is close to 38,000. Now, the swing from 2014 to 2015 is 5,000 lives. That's big. That's very fast in terms of increase. Theories abound. Yes? Yes, I was going to get there. So yes, we've done a bunch of things. Seatbelts made a huge impact. Anti-lock brakes made a huge impact on vehicle safety as well, making the vehicle people used to get ejected from cars all the time until we had seatbelts. There were a lot more roadway departures. There were broad brush kinds of things that we could do to make that number incrementally better. It turns out when there's a recession, there's less driving as well, and so there's less exposure. So one thing that we've tried to study is whether the Great Recession in 2009 really had an impact on our roadway fatality number. And it's been a slow recovery, but you would have expected, if the theory was working, that slow recovery would have been met with a slow increase in roadway fatalities. And yet it didn't. It kind of stayed the same. And I'm not sure why. They're complex dynamics. The recovery wasn't even. It wasn't even for everybody by age group, by ethnicity, and even across the country. So understanding where these increases have occurred requires sort of parsing these large national numbers like 3 trillion vehicle miles traveled and apportioning it by age group and by geography, and is a difficult modeling problem that requires the fusion of other kinds of data sources. The Great Recession took a lot of young drivers off the road. Young drivers are riskier. Those of you who are parents know this. Those of you who are younger drivers may not know this about yourselves, but you feel it in your insurance rate. And so we've been adding younger drivers back to the road, but maybe there was a critical mass. I'm not sure. It's a difficult modeling problem that I think big data techniques can help us address and understand. And it's like fusing surveys and different techniques for collecting this information can be extremely difficult and result in very sloppy results that make it difficult for our leaders to interpret and make decisions about transportation safety. So what I really want to get at here is, even though that number is down almost entirely because of vehicle safety. Occupants in vehicles are safer. People are still flesh and bones. And when vehicles meet people, people get hurt. The persistent number on pedestrian fatalities, it's been the same for about 10 years. It's about 4,000 or 5,000 a year. It's the same for bicyclists, about 600 or 700 a year. For all the progress we've made for people inside vehicles, we've made very little to almost no progress for people outside of vehicles. It's a persistent and difficult problem that requires alternative analytical techniques. So when we issued the call to action in August of last year, there were definitely places that we saw opportunities to raise this issue, right? Again, not directly observing transportation phenomenon, but understanding economic conditions. How might economic conditions impact how people are getting around, how much driving they're doing, when they're doing it, and those kinds of things. What models can we develop to identify communities that might be more at risk for fatal crashes? And commensurate with that, what kinds of interventions might we put into place to reduce that risk or de-risk those communities? They may not be direct transportation interventions. A community that might be hard hit by a housing crisis or a serious amount of unemployment might need social services that could de-risk that community. And making sure that we bring the whole of government resources available to that community could be a place that we could go. When we're looking at climate change and a lack of, either a less harsh winter or less rain, see more discretionary driving, more going out and those kinds of things. Is that creating different risk profiles for how much driving and where people are going? If we're looking at attitudes, speed, distraction, seatbelt use, everybody thinks that they're safer than everybody else. I can go 75, but nobody else should be going 75 because I know how to operate this vehicle, right? And are we finding do we need to measure different attitudes? I can speed on an urban street because I know how I can see pedestrians. My eyesight's good enough. Are we sure? How do we understand different changing attitudes and behaviors without being creepy as a federal government is kind of a big deal as well. Understanding public health indicators and other kinds of activities that are still very prevalent, right? Speed, drugs, and alcohol are still the top killers on our roads. They still contribute to about a third of all fatal crashes. And understanding how we can find new interventions or different ways to approach the way we build place or create space for folks is a very important piece to addressing those persistent problems. As much as we've done to address drunk driving, it continues to be a problem. And we can't take our eye off that ball, but maybe big data solutions can help us identify messages that work, how they're received, and public health interventions that can help us address that persistent issue. So with that, I'm excited to see collaborations across a variety of spaces, to see lots of different data sources brought to bear on this national problem, and that people are going to work on it for more than a weekend because it's very hard. But if we work together, I think we're going to make tremendous progress on using new techniques to understand this issue and address what is a potentially rising tide of roadway fatalities. Thank you.
Thank you, Dan. We're delighted that Dan is going to be sticking around with us all day and helping out with the team challenge or the challenge team formation later in the afternoon and some of our other activities. Now I'd like to welcome Linda Boyle. Linda is a professor and department chair for the UW Industrial and Systems Engineering Department, as well as director of the Human Factors and Statistical Modeling Lab on campus. She's done extensive work using a range of very innovative analytical approaches to solving problems related to human factors and transportation systems. Let me pull up your talk here. Great. Thank you.
Hi, thanks everyone. Hopefully this talk, I think, leads very nicely from our keynote speaker. I'm going to talk about the data and tools that we use to understand and help enhance road user safety. So as mentioned, I work in the Human Factors and Statistical Modeling Lab. Our mission is basically to provide knowledge on operator behavior. Why do crashes occur and injuries? And how do we actually design systems that can account for this interaction among the human system and the environment, with our ultimate goal basically to enhance road user safety. So our overall goal where we look at road user safety is to how to define or how to figure out how to get the road user to their destination without any injury or undue harm. And we do that based on looking at different types of safety research, from designing systems, services, and policies that can help enhance the overall road users' health and well-being. And we actually use many different tools to identify factors that can help reduce risks as well as enhance safety in the transportation network. And some of the tools that we use are as follows. We actually have instrumented vehicles, driving simulator studies, and we use a combination of different tools to basically get a more complete picture of an understanding of the user. So there's not one specific tool that can actually give you the full answer. So we use a range of things to basically take into account the spatial and temporal nature of what goes on. So when we think about designing safety systems, whether they're inside the car or out on the road, we have to think about how people actually adapt to these different systems. So the designers, when they design things, has an impression about what the user is going to do. However, immediately when they get it, they hope that the user will actually increase or enhance performance. And at some point, they're going to just level off because they can't just continue to improve performance. But they're hoping that if the system is no longer there for whatever reason, whether they get into a rental car that doesn't have that system, whether they're on a road that doesn't have that variable message sign, they still learn some positive information from it so that they have positive transfer of information. However, oftentimes what happens is when people are no longer exposed to a system, they go back to their normal driving behavior. Or even worse, and it was mentioned earlier about autonomous vehicles, is that people actually become so accustomed to the system that they no longer actually function by themselves, and they actually have negative transfer of behavior. And so these are all things that we look at and try to understand why. So when you look at this, this is not a linear relationship, and there's a lot of variations associated with it. And what we try to do is capture what those differences are. And we do that using a combination of many different data sources. So we look at things that are related to more the initiating factors compared to mediating factors. The initiating factors are things that are based on the actual risks given the system interaction at a specific time, along with whatever the environment is. And then every time the driver is exposed to a particular condition, they learn something that basically, impacts their next driving behavior. And oftentimes we get information about their mediating factors, which is their perceived risk. So given their actual risks, and that as time goes by, they have a perception of what can and cannot work, and they kind of change their behavior associated with it. So we see this as a closed loop, and then we try to get information on each part using either naturalistic data, which I'm going to talk about in a little bit, either survey data or licensing data, retrospective information, as well as trying to get some more information on real time using driving simulators or test tracks. And that whole group of information gives us some information about what the safety outcomes are and how they might change or moderate their behavior. So given my presentation, because I have a short period of time, I'm just going to focus on the naturalistic driving studies right now, because that's a huge area, and it's growing given the fact that we are able to collect so much information on sensors. So in the naturalistic part, we can actually get some information about their direct or immediate system interactions. Naturalistic driving studies are fantastic in terms of they can capture driver-initiated activities and tell us the potential for how drivers may adapt to various system interventions over time, because we collect oftentimes this information over weeks, months, and years. And they provide insights also into the driving behavior to help us identify the context for these safety-critical events. And so the research that I've done, usually with NHTSA, National Highway Traffic Safety Administration, or with FMCSA, the Federal Motor Carrier Safety Administration, is to look at passenger vehicles as well as truck-related crashes, and whether or not, if we give them some information in the car, whether or not that feedback can actually provide some insights or make them improve on their driving, or better yet, just to get a glimpse as to what they're doing. So for example, there was a study that was actually done at the University of Michigan looking at earlier adopters of adaptive cruise control. How many of you know what adaptive cruise control is? Wonderful. So for those of you who did not raise your hand, it's basically a system that's kind of like conventional cruise control, where you can set it at 100 miles per hour, and then if a car cuts in front of you, you can it will slow you down, and then once that car is gone, it will speed back up. So the way the system works is it's based on the difference between the distance between you and the car in front. And what you could do in naturalistic data using field operational tests is you can track the trajectory of the information and identify when a conflict may occur and when they actually may get into a near crash event, in which case the system would actually give you some feedback. And we can get tons of information on this using naturalistic data. And we can actually parse it out by looking at individual responses to likely vehicle events. So this is just two cases where there's somebody who basically may have been in conflict because they're just following really close. And then there's another one where basically the test vehicle, the vehicle that you're in, basically is not slowing down as quickly as the car in front of you. And so we can see exactly when the adaptive cruise control system would actually engage and how long it takes for the driver to respond if they choose to respond. So it's nice to be able to see all this information. However, with naturalistic data, there are challenges associated with parsing out what that information is. And it's greatly influenced by variations in people, in the types of vehicles, because it's not controlled. There's different types of road conditions. And even like if we were just basically parsing it out by just a freeway, one freeway on one road is very different from another freeway. And that's the same thing with weather conditions, environments. And then the measurements that you collect, because it is the real world, is actually greatly impacted by many things around you, including the adversity of the weather, there's lighting, there's glare, and all that can impact how we actually capture the information. And one single variable of interest may actually be many factors given the lack of control. So there's variations even in the variable of interest. The other thing is we don't have equal sample sizes. We just collect the information ad hoc based on the information that we get. So as an example, let's think about observing driver distraction. The impact of driver distraction on crash risk, oftentimes when you look at some of these statistical models, it's either they're distracted or they're not. Or is it? When we think about driver distraction, it's highly dependent on the type of distractions that they're actually engaged in. Are they talking to a passenger? Are they eating? Are they playing with a mobile device? And even if they are playing with a mobile device, what type of mobile device are they using? And also, where is that mobile device located? Is it basically Bluetooth? Is it on their lap? Is it in their purse? Is it in the back? And then what's the actual interaction that they're having with this device? So all these things actually have great impact on how we look at distractions. And I'll give you some examples. So let's say we're just looking at dialing, cell phone dialing. So actually there are some studies that show that break reaction time seems to be quicker when they're using a cell phone. Or is it? So if we take a look at naturalistic data and we compare all this information, we may actually find out that this information is related to the type of dialing that they're doing. So there's a small group of people that are actually still doing touchscreen dialing, even though it may be illegal. But then there's more people that's doing handheld dialing, and then the majority of the people actually now have systems where they do Bluetooth dialing. And you can see there's different distributions associated with each one of them. But because the Bluetooth dialing, which is the majority of the sample size, 900 out of 1,000, for example, you would see that it would skew the data over to one side. So even if we were to focus on these two distributions, the touchscreen dialing and the Bluetooth, we may actually find something else, which is that the number of observations per person would vary greatly. So for example, in the touchscreen dialing, maybe there's 75 participants, or only 1 to 3 observations, or only half of the sample is unique. Whereas in the Bluetooth dialing, we may have 90 participants that have like 5 to 15 observations each, or 1/10 of the observations are unique. So these are all things that has to be taken into account. So this is when we do these types of analysis, we have to consider how much of it is repeatable. So these repeated measures basically can be not just by person, but by the number of vehicles, by the number of days. And these observations, they are correlated. And so if I normally drive 70 miles per hour, then in another situation, I might drive 72, 75, but my variation may be very different from somebody who drives at 30 miles per hour, and they jump up and down from 30 to 40 to 50. But that average, even though it's lower than mine, we have to take into account what that variation is among those people. So these participants are observed over very different conditions that also has to be accounted for. And the participant is measured also at different time intervals or trends over times. So oftentimes when I'm showing this, people go, it doesn't matter because the general trend when we're collecting so much data, it should just be the same. Or is it? So let's take a look at a very simple example. Look at these variables. So if I look at the relationship between A and B, I can say, well, this looks like it's positively correlated. So if whatever happens to A is associated with B positively. Or is it? What if I tell you that this is actually 3 participants, and the 3 participants' data looks more like this? So in other words, it's not really positively correlated. It's actually going in a completely opposite direction. And if you do not account for that, the fact that it's repeated, you're going to actually miss this complete outcome, and your inferences will be very, very different and wrong. The other thing about naturalistic data is that there's a lot of data cleaning that actually has to occur. So those of us who actually embark on this has to really think about this very carefully. The first thing is, what data is actually available? What is it that you want to get, and can you actually pull out the information that you want to? And once you understand what you want to pull out, at what level do you want to actually examine that data? Is it going to be at the trip level? Is it going to be at a specific event? Is it going to be more sequential, periodic, or intervals? Is it going to be over days, hours, minutes, etc.? And are you going to be including video data? So going back to driver distraction, oftentimes I have to look at the video data to see specifically what type of distractions that they are doing. Data reduction for video data, for those of you who've never done it, is incredibly time consuming. And you have to basically spend many hours just going through it, creating programs, having video software that actually looks at this. And the data collection for these, especially for naturalistic data, can expand very long periods of time that has to be accounted for. So I'm actually very fortunate. I have a lot of undergraduate students working with me. So I'll give you an example of a study that we did that basically looks at this. So we used field data for a roadway departure warning system. This is also data that was collected at the University of Michigan. Their goal was basically our goal was to identify the impact of driver inattention on drivers' lane keeping ability. So there are studies that actually show that if you're distracted, you actually may weave off the lane a little bit more than you normally would. So we wanted to take a look at that. So how would we actually do that using naturalistic data? The first thing is we wanted to observe what is encompassed in driver inattention. So driver inattention can actually include eyes on road time as well as eyes off road time. The other thing we want to make sure that we can capture is the standard deviation of lane position. In other words, the variation in their lane position over time. So the driver inattention data, the eyes off road and the eyes on road, this all has to be parsed out, and you have to understand what goes into which bin. So the eyes off road time is that you glance away from the forward roadway, for some non-driving related reasons, such as like you're using your smartphone, you're turning on your radio where you have to actually turn your head. However, there are situations where you're distracted, but you're still looking forward. So you can be talking to your passenger, but you're looking forward, or you're smoking or something. So basically, anything that's related to driver distraction that may actually impact, what you're looking at, because oftentimes we could be looking but not seeing, or we're basically cognitively distracted. We wanted to be able to capture that as well. So these are the differences between drivers eyes on road compared to drivers off the road. The thing with the data reduction is the data that we used was basically, it included driver's face images and it was recorded at 10 hertz. So again, another challenge with using driver video data is that you have to understand that it's very rare that the entire clip is going to be usable. So you have to account for it, and you have to clean it. So there's difficulties, for example, in discerning people who have sunglasses. I can't really see where they're looking. And there's also other environmental issues that can actually impact what's looking on. The other times is it's going to be actually very difficult if I'm just looking at the video, so we have to compare this with the driving performance data, is that they're looking off-road for driving-related reasons. For example, they're trying to change the lane. And same thing with drivers on-road. So all these things have to be very meticulously examined and looked at before we actually move forward with some sort of a data analysis. The other thing that's very important is that we have to actually capture the right segments of data as we move forward. So if I'm looking at something that's a two-lane rural road, I want to make sure I'm still looking at a two-lane rural road when I'm comparing these different situations. And we have to parse it out so that we can identify which aspect of it is actually inattentive and attentive. And there may be just areas that is unknown. So all of this stuff gets captured as part of what we're doing. So you can see this is actually a very long process. It's very important though. So I'm telling you this just because I just want to make sure that for those of us who are moving forward, looking at transportation data, there are many different challenges associated with it. But that doesn't mean that it cannot be overcome, and it is very important to try to gain some insights on it. For this study, our study findings were, as you would expect, that long eyes off road time had a significant impact on maintaining the lane position. And just one snippet was that for two-lane rural roads, there is standard deviation of lane positions. In other words, their variability could be as great as 0.8 feet. So that's actually quite large, and it's something to kind of think about when people are inattentive. So for this presentation, I just focused on the right side, which is the naturalistic studies. But in reality, we actually need a whole gamut of stuff to look at when we're doing data analysis or looking at driver behavior. It's actually very important. This whole spectrum of things is things that we actually look at as part of what I do in my lab. And what you see is that as you get closer to the right side, you get closer to the real world. The problem is you get closer to the real world, you have less experimental control. So it's really important to have all spectrums of the information, because you might want to, if you see something on the naturalistic setting, where you see people doing a certain type of driver distraction activity, for example, or speeding in a specific context, you may only see it, even though it's thousands and thousands of hours of data, you may only see it for like maybe one or two situations. So you want to be able to repeat it and see what happens over and over again. And that's where the controlled settings actually become very important. So the driving simulator studies on the other end of the spectrum provides actually repeatable outcomes, and we could actually get closer to an equal sample size so we can be comparing things more equally and have more homogeneity of variability. And it can also provide us the opportunity to look at various types of road and vehicle improvements before we actually deploy it on the road, where it could actually be much more expensive. The same thing with guiding advanced driver support systems. All these safety systems that we're putting on the road, it's actually safer to be testing it in a more controlled environment and looking at it in more extreme conditions before we actually put it on the road and where somebody could actually get hurt. So I want to go back again to looking at this figure that I had earlier, which is when we're looking at transportation data and trying to understand the makeup of a human being, we have to understand that there's many different types of data that we need. I talked about the naturalistic studies, but at the same time, driving simulators are very important. And oftentimes, what people say that they'll do and what they actually do are two different things. So we want to be able to capture both the perceived as well as the actual risks and be able to compare that. Because even though they may not think that that's what they want to do, if they don't feel like that they want to do something, they're not going to do it. If they feel annoyed, we want to be able to capture all that information. And we want to look not just at crash data, but crash data, hospital data, licensing data, so that we can get this complete picture of what the human being is. So in conclusion, I just want to say that new safety issues will continually arise as we move forward with different types of automation, different systems, different infrastructures, and there are complementary aspects for all the different data sources that we have in the transportation domain. They help us identify differences between and within tools, and we want to be able to validate these findings and also identify how they relate to these individual differences. So in my mind, data-driven outcomes are incredibly important, and they help us identify not only associations, but causality, depending on how we actually design our studies. And it provides us a validation for the framework for driver modeling. And this triangulation of data sources becomes incredibly important so that we understand what happened in the past to design for the present so that we have a safe future. Thank you. Did you want me to ask? Oh, that's fine.
Thank you, Linda. You and Dan have done an excellent job of setting the stage for why we're interested in working in this space and also some of the challenges that face us in heading into this Transportation Challenge event. We're going to shift gears now and welcome up our first panel of the day. This panel is focused on how cloud computing can enable transportation data science. We're excited to say that we're partnering with the three major cloud providers in the context of this challenge. So we have support and sponsorship from Amazon Web Services, Microsoft, and Google Cloud. And there'll be representatives from those organizations here today. So I'd like to welcome up, without further ado, as we say, Bernice Herman is going to be moderating this panel. Bernice is a data scientist with the eScience Institute, and I believe she's going to introduce the panel members. So panelists, please come up and join us. And please sit in your assigned seat so that you're appropriately labeled on the live stream, unless you would like to change personas for the panel.
All right. Well, thank you, panel members. Thank you, Sarah, for the introduction. So I'm going to introduce the panel, and I guess we'll start maybe from the left going forward. So we'll start with Ed Lazowska. He holds the Bill and Melinda Gates Chair in the Paul G. Allen School of Computer Science and Engineering at the University of Washington. He also serves as the founding director of the UW eScience Institute and was the founding chair of the Computing Community Consortium. Rob Fotland is the director of Cloud and Data Solutions at the University of Washington IT. He has a PhD in geophysics and has formerly worked at NASA and Washington Research, or Microsoft Research. His interests are data science across the full spectrum of acquisition to collaboration. Vani Mandava is the director of data science outreach at Microsoft Research. She has over a decade of experience designing and shipping software projects and features and has enabled the adoption of data mining best practices in various version 1 products across Microsoft. Franz Lowenhurst, hopefully I'm pronouncing that right, okay, is a principal planner for the city of Bellevue. He received his master's degree in urban planning from the University of Washington and has more than 20 years of transportation sector experience. Franz is project manager of the Video Analytics Toward Vision Zero partnership. Last, we have Will Curran. Am I pronouncing that right? Okay. Is the program manager for Google Cloud's Public Datasets program. He's been working with NOAA for the past 18 months to solve cloud distribution challenges and improve accessibility of several large weather data sets. He's previously worked on cloud technical programs and platforms at Disney, Amazon, and Microsoft. Thank you very much, panel, for joining us. So I'm going to give each of you a couple of minutes maybe to discuss what you've been working on recently. And with that, answering the question, who is doing transportation data science out there? We'll start with Ed, maybe.
Let's see. I'm going to answer a slightly different question, as I always do. Getting universities onto the cloud and getting corporations onto the cloud is like kicking a dead whale along the beach. It's been incredibly difficult. And the reason is that at universities and enterprise corporations, there are people whose livelihood depends on running computers. It's what they've been doing for many years, and they're still doing it. We had a really interesting presentation here a month ago from Andy Jassy, who runs Amazon Web Services, talking about the fact that corporate clouds private clouds are finally failing. And the evidence is that 5 years ago, AWS would approach Fortune 100 enterprise customers, and they would never get higher than the CIO, and often not that high, and they get politely listened to and then ignored. And now what's happening is CEOs are calling them and saying, come talk to me, and the CIO is not in the room. And I'm sure the same is true for Google and Microsoft, right? So the interesting thing is that CEOs and boards are finally figuring out that the CIO sold them a bill of goods some number of years ago. We can do it more securely, we can do it less expensively, ... The real answer is they were preserving a style of work that they were good at. It's been even slower at universities because we have all kinds of hidden subsidies that cause on-premise computing to appear to be artificially inexpensive to researchers in particular. So what I think I've been trying to work on in recent years is kicking that dead whale along the beach, and that is encouraging the use of the cloud by researchers. Our business operations at UW are finally going to a cloud-based HR payroll system. But the truth is most researchers are still using on-premise computing. All of the economic arguments for using the cloud ignore the most important reason, and that is that sharing is easy. Okay? And these transportation challenges, as you heard from the introductory presentation, require the aggregation of large amounts of data from lots of sources in order to get reasonable amounts of data that you can draw inferences from. So the ability to share data is critically important, and that's one of the really major benefits of the cloud.
Great.
That's my story.
So hopefully I'm helping Ed kick the whale down the beach. I'm not part of the whale. So a little part of the second piece of the UW perspective is, so I work in cloud computing and adoption and research. And, cloud computing is a new technology, and a new technology is something that you can describe to somebody and they may say, oh, that sounds really great. But from my experience, and this is just me personally, I don't really get cloud until I do something on the cloud. So we're about to start democratizing that for the students. We're trying to get students to where they can start using the cloud. And one of the things we're going to do is train them to turn off their machines, because the cloud is a utility model. So maybe we'll lay out $21 bills, and I'm going to say, okay, you have to give me $1 every 30 seconds until you turn off your machine. Because you can say, I can turn off my machine and I don't have to pay for it. But when you remember to turn out do that at the end of the day, then you're not paying $1 a day for those 3 HIAC blades that you're paying for on the Amazon cloud or whatever the rate happens to be. So that's one of the things we're doing. We have about 6 or 7 different initiatives on around cloud adoption. So they have to do with things like collaboration, showing how easy it is to share data. We have a data security initiative. We have a scale task. We're trying to show that the cloud has the ability to scale up and really do important research computing. As far as what's going on in transportation, I'm aware of 2 things that I'll mention briefly, and they're both really great illustrators of the spectrum of technology that we talk about. The first one is Mark Hallenbeck, who's sitting back there. He has Orca data, and we've dropped that onto the Amazon cloud into a database.
Sorry, for those of you who aren't from here, what's Orca data?
Oh, sorry. Orca is the Puget Sound public transportation system. And my understanding is that this data is primarily when people get on the bus and they ding their Orca card, and that registers as a data point. And so being able to map the way that that system works against the usage is a big part of that project. And the reason I mentioned that project is because it illustrates the principal goal of the cloud in my mind, which is to forget that you're using the cloud. Okay, so the cloud has these great advantages, but you don't want to be sitting around thinking about, oh, I'm on the cloud, oh, I'm on the cloud. You want to be focusing on your research. And I claim that in that project, we were able to fairly quickly get the Mark's team working on their research problem, not thinking about what the implementation was or patching the operating system. And then the second thing that I'm aware of is Muhammad Ali is a guy who used to be at Microsoft. And when he was there, he put GPS receivers on the Microsoft shuttle system and started tracking that data. And he used that data stream to start developing something that's now, I think, called Stream Insight, which is part of the Microsoft technology stack. And that's the ability to take IoT devices and watch the flow of data going by and look for particular characteristics and events. And that, maybe we'll get into this more in a subsequent comment on this panel, but the basic idea is that you have to have successes that are based on real case studies in order to start streamlining the process. So that's something that we're really interested in. Mohammed is now down at UW-Tacoma, and he works with students on transportation-related problems also. So I'll stop there.
Yeah, so my current job is to empower academics to use the cloud, and we do that through giving them cloud computing credits and data science tools, and we also teach them how to use it. Over the lifetime of the programs that we run out of Microsoft Research, we've empowered over 1,200 projects in universities, and I stay fairly optimistic given what's happening in the research landscape and given champions like Ed and Rob that we are on a good trajectory there as far as cloud adoption is concerned. So I'm not a transportation expert, and in order to prepare for this panel, I sent some feelers out in Microsoft to find out who else is working with transportation data in Microsoft, and I was pleasantly surprised to see the number of groups that are involved in this effort. Some of the ones that stood out to me was, Microsoft has a connected car strategy, and they are working with OEMs. They have an alliance with the Renault Nissan that is planning to release more than 10 connected cars with autonomous driving software by 2020. Sila, which has a team for community technology engagement, has been working with DataKind Vision Zero, and they've engaged with the city of Seattle, the city of New Orleans, and New York City on some of the DataKind Vision Zero. I'm sure there's a lot of you here who know about this effort. They've managed to successfully engage students through their fellowship programs to build predictive models that improve traffic safety standards in these cities. The Bing Maps team is integrating geospatial information and artificial intelligence in many of Microsoft's products and services. That's going to generate a lot of data, and it's quite fascinating to see where all of this technology is going. The data group in Microsoft has built predictive models on the NHTSA fatalities data that can predict with pretty good accuracy, over 90%, the severity of accidents or incidents as they're referred to now. So there's been quite a lot of effort, and there is a specific group within the community and tech engagement whose job it is to engage with the community on transportation scenarios. So it's been interesting to work with the big data hubs on this challenge, and I'm sure that we'll have a lot of interest from within Microsoft to engage on this.
Thank you for the opportunity to join you today and speak on the City of Bellevue's Video Analytics Towards Vision Zero partnership with Microsoft and the University of Washington. As many of you know, Vision Zero is an international movement aimed at responding to what is one of the top 10 leading causes of death worldwide. An estimated 1.2 million people die on our roads worldwide. And at present, the transportation industry is in reactive mode. We rely on accumulation of police crash reports at a given location to accumulate before we undertake an investigation of what kind of corrective measure might be implemented. And clearly, there are some limitations associated with this reactive model. Notably, there's due to the rare and random nature of crashes, it often takes many 5+ years for crashes to accumulate, for a pattern to emerge. And in recognition of the opportunity to enhance public safety, City of Bellevue set in motion a partnership with Microsoft UW that now incorporates multiple other research, government, and nonprofit institutions in developing technology that relies on cloud computing, machine vision systems that are informed by deep learning algorithms to object classify, detect the movement of vehicles from our existing infrastructure, our traffic camera network, documenting their trajectories, their speed, their behavioral patterns, so that we can then start to deduce near traffic collision events, so that we can create a proactive model and get out ahead of those crashes before they occur. We're making steady progress in the partnership. Our deep neural network DNN algorithms are at a 95+% accuracy for motor vehicle. It's less adept with pedestrians and bikes, and I've left outside a postcard that I'd encourage you to pick up along with the brochure on the partnership. And the postcard speaks to a coming attraction, if you will. We're getting ready to launch a crowdsourcing initiative that invites the public to create a curated data set to inform the DNN algorithms, meaning people will be invited to object classify ped, bike, and auto to enhance the ability of the system that's being developed to better classify all modes so that we can create our city's street system, make them safer. Ultimately, the system that we're developing will migrate to a trusted data platform. This is a nonprofit entity. We're in early stage conversations with the University of Washington to host this TDP framework, and this would allow jurisdictions throughout the world to create data vaults and then share those data, that data with research institutes, so we could start to do a deep dive into the kinds of topics that Daniel was speaking to in his introduction, whether patterns emerge by time of day of week, seasonally. Do certain kinds of corrective measures yield better results than others, so that we can start to make more informed decisions about the investments we make at the municipal level. So I would encourage all of you to get involved, join the many others that are already affiliated with this, and check out the website that is referenced on this postcard. Thank you very much.
Great.
Hi, I'm Will Curran. I manage the Public Datasets program for Google Cloud. I've been working on the Public Datasets program for about a year now, and we've been working with various public datasets to get them onboarded and make them accessible. I see the program as not a a way to get more data sets onto one specific cloud, but to work with collaborators and other platform partners and just get more data sets onto the cloud to increase accessibility. One of the challenges I see is, to respond to your question, is not just with traffic data sets, but with any of these public data sets, is the true value in these public data sets is an access model where you can fuse the data, like we heard in the keynote, and do interesting joins across a variety of data sets. Often when someone thinks about the value of weather data, for example, the true value of a lot of these public weather data sets is the ability to join them with other data sets, like whether you're doing medical research, transportation research, economic research. And so one of the challenges I've found is that there are not a lot of common join keys in these various public data sets. And so there's a significant amount of ETL you have to do, like whether you're looking for location joins. People doing geocodes, lat long, state, zip, ZPAC. So one of the things that I'm interested in is working with platforms and data providers to establish kind of high-level schemas for data to facilitate better join keys, so as we onboard more data to the cloud, users have more access across a vast amount of data sets to do more complex and interesting predictions.
Great, thank you. So with time, I think I want to open the questions up, and if there are no questions in the audience, we'll move on to my questions. Any questions out there? Oh yeah, if you would come to the mic. All right, on to me for now at least. So I have a question. Are there any data confidentiality or privacy concerns when moving to the cloud, especially with this raw transportation data that may have personal information or disaggregated data, maybe from the census? Not everyone needs to answer, just.
Sure. So in formulating the partnership that I spoke to with Microsoft, it took 6 months to create the agreement. We are onboarding multiple other jurisdictions at this time and are creating a more streamlined agreement to address the privacy concerns, retention of data concerns. A lot of the video imagery that we're working with is low res enough that it really is, it's not feasible to determine who the individual is. That said, there's always sensitivity on this topic, so that's why we have agreements in place to respond to this topic. We tend to use the term Big Brother's counting, not watching, to address some of these concerns. So that's how we've addressed it.
Great.
Yeah,
There was actually an interesting event that happened, I think about 2 years ago with, it was one of the first transportation data sets that was made public. It was the New York taxi data set. And I don't know if you remember the kind of guffaw around that was that even though the providers that had submitted the data and made it public thought that all the PII was cleared, several analysts on the web were immediately able to produce blog posts and kind of deduce different routes and drivers and publicize that. So I think that a lot of times we think we're clearing out that PII, but there's a fair amount of due diligence on the part of the data providers and the access providers to make sure that we're protecting privacy.
And this story about de-identifying not quite work is a story that we've been hearing again and again for the past 10 years, right? And we're going to continue to hear it. The Orca card data that Mark Hallenbach worked with and Rob has referred to is a great example. We all have these cards. There is an ID on the card. Somebody holds the mapping of IDs to individuals. We've had this problem just on the UW campus because our IDs, which include an Orca chip, are being used by more and more services around the campus who need to map it to a particular individual in that person's account. So suddenly the database mapping essentially the hashed ID to the individual is distributed around to a bunch of people who may not have the security of the one centralized database where it used to reside, even if you think that's secure. So there are just enormous problems here.
Yeah, and there's a lot you can accomplish while meeting privacy standards. So the particular project that Franz is talking about with Microsoft Research and the city of Bellevue is running on a hybrid cloud model where the data is processed, the video data is processed as soon as it comes in, and none of the videos are actually stored. All this is running on premise, and it's only the analytics that are then sent to the cloud using DocumentDB, which is Microsoft's NoSQL cloud service. So it's very useful to run this sort of model in a hybrid cloud implementation. And there was a comment in the fireside chat yesterday about how it's possible to store the analytics in the cloud and not the data that could potentially have privacy implications. So that's something to keep in mind.
But this implies that the security of the cloud is the concern. And in fact, I have less concern about the security of your cloud or Google's cloud than I do about our on-premise computing.
Absolutely.
Yeah, that's the one comment I was going to make, just to agree with that, is that the cloud itself is a very secure platform with measures put in place and encryption and so forth, and we work really hard to do that, but then it's the human component that's the actual security issue.
Okay, great. Thank you. I guess another question I have is moving to the cloud kind of converts you from a primarily fixed expense with on-campus or on-premise computing to a more variable cost expense in some ways. Do you see that as a financial benefit to places like transportation agencies or academics who are pretty used to these fixed expenses? Or are there more alternatives in the cloud to get closer to that fixed expense model?
Are you talking specifically about moving data over?
Yeah, I guess there's two sides, the storage and the transportation of data and the analysis.
Just for moving data over, there's really three parts of data. There's the ETL and processing of that data, which is compute intensive. There's the hosting of that data, and by that I just mean putting it on the cloud in buckets. And then there's also the access model for the data. So whether that's using products like BigQuery, Athena, different SQL access models. So for each of those models, there's absolutely cost savings to putting them in the cloud. But more importantly, what they do is they in addition to reducing the overall cost of those three segments, they distribute the cost. So for example, with NOAA, they're pushing a lot of their data distribution out to Azure, AWS, and Google. And what this does for them, since they own very large data sets, like we're talking like hundreds of thousands of satellite image data sets, their major cost wasn't in actually hosting the data, because hosting costs are approaching near zero. But the egress costs were enormous. So, and they have thousands of users wanting this data from their servers. So by distributing this to platform collaborators, they're able to push those egress costs over to user egress pays or platform pays. And so those costs move away from NOAA.
Yeah, could you define egress?
Yeah, oh, I'm sorry, yeah. So egress is when you want to transfer data out of network. So if you have data hosted in a data center locally with a connection to your different offices, you're not paying that egress, that transfer. If you have data in the cloud and you want to transfer that data down to do local analysis, there's an egress cost to moving that data over the network. If you want to do your analysis in the cloud, on the same cloud as where that data set lives, you're paying what's called ingress, and there's no charge there.
Great, thank you.
So let me say a bit more. Every tech startup these days uses the cloud, right? Nobody has a data center, and there are a bunch of reasons for this. And the question is, what is it that we know that they don't know that makes us smart and them dumb? And the answer is it's the reverse. They're smart and we're dumb, right? And so what do? They convert what otherwise would be CapEx into OpEx. And the variability is good. It means that if you're not using it, you don't pay for it, all right? You don't buy a bunch of equipment. You don't have to procure for peak capacity, right? Which otherwise you would.
Also a startup, so they're often starting net new.
Sure.
They don't have this legacy model.
That's exactly right, okay? Jassy said the other day that 80% of Fortune 500 companies still have a mainframe. That's how slow it goes. And that's another advantage of the cloud. It is continually renewing itself, right? So the equipment gets better and better and better, whereas the thing you buy is something that you live with for God knows how long. This university is full of systems that are 10 years old and that have no business still existing except somebody CapExed it in 2007 and it's still running. This is just craziness. You have the wealth of applications that Microsoft and Google and Amazon provide, which is vastly more than any single enterprise can provide. It's arbitrarily scalable, on and on and on and on. So this just only makes sense. For those of you who aren't from Seattle, Paul Allen has a wonderful museum downtown called the Living Computer Museum, where he has resurrected all kinds of computers and made them run. And the most recent one is a CDC 6500. And I tell this because this was Purdue's computer, and it ran there for like 22 years. I mean, what good was the CDC 6500 20 years after it had been introduced, except that they'd already paid for the thing. And at universities, Santa Claus pays for the power, and Mrs. Santa Claus pays for the cooling, and the elves do the backup. Right? It made no sense to have this machine.
Great. Thanks.
So I just wanted to chime in. Right now with the partnership we have underway, we're still in research mode. So ultimately, what the cost is of the trusted data platform configuration remains to be seen, and how that cost sharing occurs remains to be seen. But I think it's important, again, bringing it back to the topic du jour of how to address roadway crashes. The National Highway Traffic Safety Administration has estimated the 12 million, Daniel, was that the number you figured, that we experience more or less every year, to be in excess of $800 billion annually cost to our nation, both in societal and economic expense. Now, how that cost sharing, the opportunity cost of not responding in a proactive manner and continuing to do business as usual, the cost of business is, the way that we're rolling right now, it needs to be taken into account as we think about, as a society, how we approach traffic safety. I'm going to continue to bring us back to the roadway topic.
Mm-hmm.
So
Absolutely. Yeah, there's
Great.
Quickly,
yeah,
there's a little angel on my shoulder that just needs me to chime in here. That I love the cloud. I've been working with cloud for a long time, and there are just many benefits to it. But I do want to recognize that there are costs in both learning and transferring and shifting workloads up to the cloud. I mean, there's not a button that you press and you're just magically on the cloud and everything's cheaper and better. So, and I can talk with you about that offline.
Yeah, and it's important to move the conversation beyond just the fixed versus variable pricing, because in industries where the demand is there, these cost models and the commerce platforms are evolving, such that large contracts can be done. It's great to get into a conversation about CapEx versus OpEx in the academic setting. There are a lot of cloud consumption patterns that make sense, in industries that are mature enough to have made this shift to the cloud. They rely on per unit pricing, and it's been fairly effective in these industries. So I would encourage academics to also really look at the services that you need and how much they're going to cost. Things like serverless computing do make cloud adoption cheaper.
Great. Thank you. We have a question out here.
There's a wireless mic too, so as I'm talking, anybody else who has a question, just raise your hand and we'll just sort of go in order and bring the mic to you. My question is, for thinking about the 6 months in Bellevue to sort of create this pilot. It's a long time frame for a pilot, and the time, there's not so much time. We have a few months for this challenge, and so I'm wondering how, for each of you, that the hubs, the NSF, can leverage this collaboration over the next few months to surface and scale everything that you guys are working on and make such a clear case for. So how can LA do the same thing that Bellevue is doing? How can UCLA do the same thing that UWash is doing? What are the biggest ways that we can help you to scale everything so it reaches a national scope?
just to clarify, the partnership that we did create with Microsoft, it did take 6 months with the back and forth of legal, et cetera, to address the privacy concerns and so many other topics that are associated with that agreement. Hopefully, some of those aspects are going to be more streamlined going forward. And indeed, San Francisco, you mentioned LA, they are also part of this partnership now. So the onboarding process has gotten easier to the point where, you know, we are creating some standard templates so that jurisdictions aren't going to go through the extensive lift that was required for that initial effort.
I have a comment on this. It's sort of the mantra for my job, which is that if you want to scale a solution, you have to create a cultural shift. When you solve a problem, take 5 minutes, take 10 minutes, take an hour, and go and write it up so that the next person who comes along doesn't have to solve the same damn problem. So we have an entire cloud technical website called cloudmaven.org where we've been fastidiously, in quotes, doing that. And that's what I'd like to see happen here also. GitHub, right? That's the one-word answer.
Great. Another question?
Okay, I'd like to throw out a hopefully hyperbolic and provocative enough topic that will keep you going for a while. And I'd like to pick up on Ed's challenge about the cloud is about being able to more easily share data, and say that's absolutely the opposite. That we built the internet and the World Wide Web originally to share data from CERN, for example, and that the universities are connected together via internet too and so forth, exactly so they can share data. I think Amazon and Google and Azure are great services, and they're great ways to build infrastructure and to put things out there and make things accessible. But the challenges in sharing data from a research university perspective are infrequently about where you house it and more about the details of what those data are and making your collaborators know that they're there. It's about the relationships, like Will was talking about, the metadata and the directory, and getting your research questions established in a semantic that makes sense for the data that are out there and knowing where they are, and less about where the data are located. And that's, I think, evinced by the fact that there are egress charges at these providers. As soon as you talk about using Google's cloud or Amazon's cloud or Microsoft's cloud, you're no longer talking about the cloud, because the cloud isn't any premise. It's about the relationships between the different systems that are all connected together.
Well, just to clarify, when you talk about, like, there's an egress cost connecting between all the universities. You're not being billed for it, but it's there. It's part of the cogs of having all of those local systems. And for most, and correct me if I'm wrong, I believe that, like, especially with the NOAA partnership, the egress is free for users for the NOAA data sets on Azure, AWS, and Google, and also IBM. So, I mean, you know, there's a business side to this, of course. You know, we want to build more awareness to users to use other processing on the cloud, right? Like having the data there and not providing that egress cost encourages users to come on and then also do their ETL and processing there. So that's, you know, that's like the reason we have these programs, you know, as from a business perspective. But I would challenge that, like, there's inherent cost in having all of these data sets distributed through all of these various data centers at universities that you don't realize that you're paying, but you are paying. And Ed can probably speak to that.
I was just going to comment. The way I interpret what you've said is that the semantics of sharing are a significant barrier, and that's absolutely true. And it's true whether the data is in the cloud or on premise. Okay, so that it doesn't go away. It doesn't get easier, probably. On the other hand, I think all of us have experience where the ability to collaborate with someone who we otherwise had not collaborated with is vastly easier because things are in the cloud. And you know, there's data, there's computation, there's something as simple as Google Docs, which just makes things vastly easier than they otherwise would be. The ability for us to collaborate with people at the Pacific Northwest National Labs is vastly easier when they can sneak themselves onto the cloud, as opposed to us getting them UW credentials, or, God forbid, them getting us Department of Energy credentials. Okay, so a lot of things really do become easier in that world.
Okay. Oh, quick comment.
Yeah, I was just going to say that, you know, the the direction we're headed with this partnership of creating a trusted data platform within which there would be an established trustee, potentially the University of Washington, who would then interface with the multitude of municipalities and other universities who would want to participate. And then also to have the ability to normalize this data set. Daniel was speaking to the toothbrush analogy, which was kind of an amusing one. This would allow for the ability to normalize and see data across, internationally, both in this country and elsewhere, and to work through a lot of these issues that we're still grappling with every time we launch one of these research endeavors. So that is where we're hoping to go when we go from research to implementation, is having a trustee of a TDP format facilitate that onboarding.
Great, and we have final question out here.
Hi, am I audible? Okay. So my question is regarding the data integration which we have to do on the cloud. So as a data scientist, I face a lot of problem with traffic data because of different schemas and different standards from different parties who collect the data. So similar problem exists in health and buildings data who have addressed this through common schemas. And a lot of effort is there in UCLA and Berkeley for buildings data. So is there a similar effort for traffic data to standardize the schemas so that integration and the analysis can be done very easily by non-data scientists?
Is this related? This is related to the traffic work that we're doing, or in the project that we're working on, we have researchers from Sweden, Montreal, elsewhere in the U.S. and the University of Washington collaborating on a standardized approach to what constitutes a near-miss traffic conflict event. So we are arriving at an agreed-upon synthesized approach from the multitude of approaches that exist out there, so that we do have a common schema.
All right. Maybe we'll sneak in one final question, or should we wrap it up? Okay. Very final question.
Good morning.
Just
Yes.
yell.
Okay. Good morning. My name's Robert. If an IT stack is a house, then I work in the basement. I am the dungeon master. I control the data at our company. We have hundreds of terabytes. I manage the telemetrics of about 500,000 trucks. So we have a very good team. Very simple question, dollars question. We are looking at migrating up to the cloud. However, I don't want to lose anybody in our team. Can you give me an argument, a business justification for a hybrid environment? We need time to get people comfortable with the changing environment. You've explained the difficulties in the academia of moving, the inertia. Well, I recognize it. I think everybody sees it. So tell me, how do I justify moving to the cloud, keeping the people safe? Hybrid analytics may be in the data center. Does that make sense? May I have your comments, please? And thank you for giving me the last question.
No worries.
It's a great question, and I think we should punt to the two cloud providers who must have to answer this question all the time, which lets me off the hook.
Why don't you go first?
So in my experience, there is a fair amount of learning even when it comes to adopting cloud technology, and I don't see necessarily that people are losing their jobs over cloud adoption. What I see is those who are evolving, who are willing to learn, are able to sort of preserve, their employment, and they are able to take their organization forward in adopting some of the cloud technologies or edge computing technologies. In terms of hybrid cloud, yes, a lot of the implementations that we are seeing are hybrid, and there is almost an intermediate step before you go from on-premise to cloud, which could be a multi-year endeavor that runs in hybrid cloud technology. There is a case to be made for running things on premise where you don't necessarily have a compelling need to do extensive data sharing, but you can do the analytics locally and then sort of rely on the cloud when it comes to aggregate analytics or data sharing across different on-premise implementations. So I haven't noticed. I know this has always been a concern from IT administrators, but over time, I think people are beginning to realize that there's a lot to learn and there's a lot to there's just a lot of work to do to move organizations forward in adopting this evolution.
Just give you a quick example. So NOAA, is in a similar position. And what they've done is by distributing, they're maintaining the ETL. They have a vast network of ETL. You can manage all the different monitoring sites and weather stations. They have to process all that data. They're keeping that in-house for now. So that's the kind of the on-prem story, while making the distribution model via the cloud. And what I've seen in their organizations is that the ops jobs associated with that distribution model, with distributing that data, have not gone away. They've just moved from how do I solve these distribution problems on-prem to how do I solve these distribution problems working, with Azure, AWS, IBM, Google, to solve these problems. So I think there's just a shift in the workforce, really, and not that that's just easy, but it's a phased approach. I think it's a pretty good outlook for keeping IT jobs as we move to the cloud. The work is still there. There's more and more data. That's one way to look at it. Like, the data is not shrinking. The amount of data we're collecting is growing, and then the historical amount of data that we need to preserve is growing.
Here's the comment I'd make. I think there's a direction things are clearly going, and the direction is a reduction of in significant quantities of on-prem mainframe or private cloud computing. Okay, so there are of course exceptions, but I think that in general we're moving towards sort of IoT devices and laptops as what's sort of out there, and the cloud as the provider. And I firmly believe that that's a trend that's going to play out in the coming years. And the question is how are you going to respond to that trend? I don't think it's a trend that in the long term is going to be resisted.
Okay, well, thank you, panel, for answering our questions.
Yes, thank you, panelists, and thank you, Bernice, for moderating the panel. We're going to go to a break now, and we'll come back in about 10 minutes. Sorry, it's not a very long break. And we'll have a talk by Bill Howe. Please help yourselves to the remains of what's left back there for breakfast and coffee. Restrooms are just out to the right. And if you have any questions or need logistical information, please feel free to come find us at the break. are rigging up their own systems here. More power to, yeah. There are some power strips around. Let's see. This one? Transportation. Okay. Do you want to check anything or?
And I muted that one, so.
Okay. And then we'll go
Testing. Yeah. There we go. You clear where? Here, I'll turn it on.
saw all the different, co-founders, et cetera, et cetera.
Oh, yeah. Oh, good. Good, great point. Western or West?
West. There you go. All set. It's a nice stage.
Not bad.
Can I get your attention? We're going to get going again. Try and keep things on time. Great, thank you. So it's my pleasure to welcome Bill Howe to give the next talk. Bill Howe is an associate professor at the Information School at the University of Washington. He's also the associate director of the eScience Institute. Today he's going to be talking about challenges and opportunities in transportation analytics, and he'll be highlighting some programs and projects in the Northwest in particular. Thanks, Bill.
Thanks, Sarah. So yeah, we wanted to leave a slot today to talk a little bit about what's going on locally, but I also wanted to use this time to highlight a couple of emerging challenges. We heard a lot about some of the technology resources that are becoming available in cloud computing and some of the challenges and opportunities in data, but there's a couple of emerging topics that are maybe broad in data science that I want to touch on as well that I think are acute in urban analytics and maybe even especially acute in transportation analytics. So just by way of background, my PhD is in computer science. I'm a database person. My interest in urban data science really kind of came from a few observations. One is, the opportunity for kind of enormous, ubiquitous impact in this space. If you can solve some of these problems in one city, you have the potential to solve them worldwide. 80% of the world's population is living in cities or going to be living in cities within a certain number of years. There's also kind of a timely effect where resources are becoming available, right? The open data movement has been gaining steam for a while. We heard about what's going on with computing resources becoming democratized and more available. There's more and more partners who are interested in talking about this stuff. And I'll mention, being here at a university, the demand for projects in this space from students across all departments is sort of remarkable, right? It's not just the urban planning department. It's not just, say, the computer science department. It's not just the information school where my faculty appointment is. It really comes from all over. We have people in neuroscience and astrophysics and everywhere else who are coming to work on data science for social good projects. So there's a real opportunity here to try to match make those resources with some of the problems you see. And then I'll mention that, cities are interesting to me in that they resist reductionist approaches to science. Everything's connected, and I think transportation is a really great example of this. When we talked to the Center for Reinventing Public Education here in Seattle, and most of the problems they solve are really about transportation. So why is that? We have a bunch of transportation people here, so you probably understand this effect, but why is public education mostly about transportation? This is interactive. I was just teaching a class last night. I'm prepared to wait for minutes if I need to. So. Just the money. I see. So on the cynical end, we have a response. On the more positive end, it's about access to resources. You can build schools wherever you want, but if you don't have bus routes that can get them there, then people can't make it. If you hit, 2 bus hops is more or less infinitely worse than 1 bus hop and so on. So you have to sort of partner with the transportation engineers who are doing the planning, or else you can build a bunch of schools and waste a bunch of money and not actually provide any education for people. So they're thinking very carefully about this. Housing is all about transportation for similar reasons. Social justice more broadly is all about transportation. If you can't sort of get to your job or you can't sort of decide where you want to live, this is an issue. Okay, but there's some challenges emerging, and there's 2 that I want to talk about in this talk. One is kind of an organizational challenge in that how do you do this kind of matchmaking between enormous interest among students and so on and the potential for sort of hundreds of little boutique projects that you could spend all your time kind of working on but not actually have anything that realizes the full impact. And also maybe how to scale this stuff locally, regionally, and nationally. Every city is kind of a unique snowflake. Just because something works in, New York, it doesn't necessarily mean it's going to work in any other city in the world. And yet we all seem to be talking about the same problem. So there's some opportunity there, but it's not obvious necessarily how to do that. And then the second challenge is more of I want to make a pitch for a technical direction of research all the way from computer science into applied work that I tend to characterize as responsible data science. And I'll talk about what I mean by that in a little bit. So about scaling, there's some formatting. 3, you can tell which one of us hasn't done a full logo design process yet here in these 3 organizations. It's the one that's pasted in text in a yellow box. So we have organizations that we've been building and designing and been partnering with and participating in at kind of various levels along this scale. And there's actually one that's only at the national level too that I didn't put on the slide, called the Metro Lab Network, that I'm not going to talk much more about, but I encourage you to Google it and see what's going on there. But the three I do want to mention here, one is eScience Institute, and I don't necessarily want to characterize our work at the eScience Institute as purely local, but there is a somewhat emphasis on Seattle local projects in order to take advantage of that local interest. And then there's a organization that's just been emerged with a gift from Microsoft called the Cascadia Urban Analytics Cooperative. And this is a partnership between University of Washington and University of British Columbia to look at, comparative analytics across cities. And again, as I pointed out, this is sort of the holy grail in urban analytics, is how to sort of understand what's going on, not just in one city uniquely, but across multiple cities. So how can you do this regionally? And then, of course, both regionally and nationally, you have our partnership with the Western Big Data Innovation Hub, of which I'm a co-PI, along with Ed Lazowska here, Michael Franklin in University of Chicago, Mike Norman in San Diego Supercomputing Center, and R.L. Rochem here at the eScience Institute. Okay, so a little bit about the eScience Institute Data Science for Social Good program. That was one of our first forays in this space. Again, the tapping into this interest around campus was pretty remarkable. In the first time we offered this program, there's 16 spots for students to come with us, come join us for the summer, join a team of about 4 students each, and work on some project for the quarter. And we had 140 applicants from sort of 20 plus departments. So the 140 we're quite happy with and impressive, but that spread across departments is really what strikes me. And there's one project in particular I just want to mention briefly from this first year, 2 of which had quite a lot to do with transportation, and I'll mention just one of these. So this was the observation that if you go to Google Maps and ask for walking directions from point A to point B, it will cheerfully sort of provide you those directions, but you might end up going over curbs and upstairs and through construction zones and up steep hills and down steep hills and so on, making it essentially useless for citizens with mobility issues of any kind. Wheelchair being an obvious example, but also people who are sort of pushing a stroller or who are on crutches or otherwise. So version 1 of this was this team, before we were involved, won a hackathon to show that they could make digital maps that were annotated with this kind of information, the grade and the construction zones and the curves and so on, and get out of the black market that had emerged where people in this community would pass around hand-drawn maps. They could do a better version of that. When they came and joined our Data Science for Social Good program, the challenge was to actually support those kind of routing algorithms like you have on Google Maps. But some of the problems you need to solve here are, the data is available. The sidewalk data was available, so that was a nice resource. It couldn't have been done without that. But you find that, in the open data, the sidewalks sort of do this, or they do this, or they do this or something, but they don't sort of connect where they need to, making the routing algorithm sort of impossible to do. So there's a lot of computational geometry and sort of data cleanup you had to do during this 10-week period in a big database in order to support those kind of routing algorithms. And that was a project that wouldn't necessarily be taken on under other auspices, but was a great fit for the Data Science for Social Good program. Okay. In the following year, we had another couple of transportation projects, and one that I'll mention, Mark Hellenbeck has been mentioned a couple of times today, and you'll hear from him later. This also touches on this notion of responsible data science that I'll come to in a little bit. But the overall project here was, let's take a better look at the ORCA card data. These are the card swipes that allow you to access the public transportation. It was underused. It's a gold mine of information, but it was sort of underused. That was the overarching vision. However, there's some careful things. There's things you need to check before you start getting too deep into this data set. And Mark is smart enough and savvy enough to think that these are the questions you need to answer first. So one of which is the following. The card swipe data has demographic information and everything you need to know about the rider. There's another way of counting ridership, which is pressure plate. Mark's sitting back there, so he's going to correct me if I get this wrong, but there's a pressure plate on every bus so that you get a tick when someone gets on the bus, and you know for sure that someone did get on a bus, but you don't know anything about them. Okay, so it's very tempting to think, let's do all our analytics on the ORCA card data because, boy, we have this rich data set and it sort of covers the area, and we can sort of track. It's easier to disambiguate commutes from other kinds of rides and so on. But what do you think is true about those users who have ORCA cards as opposed to? Mark's answering the question, so this is a little. They're too quiet. This is the problem. So again, my strategy is just to wait long enough, and eventually somebody talks. So this didn't take long with Mark. So it's exactly right. So they tend to be sort of more affluent, right? They tend to be employees of University of Washington and Microsoft and Amazon and so on. So if you sort of go whole hog and use that to do your transportation planning, you're going to end up designing a transportation system that's essentially optimized for the people who need it perhaps the least, right? And so the first thing you do is to check where do these two measures of ridership disagree, and how does that sort of distribute spatially and probably temporally as well. And so what this map is showing where are the differences around, this is a map of Seattle, so where are the differences in these two numbers of ridership? Where do they tend to agree and where do they tend to differ? And what you find is that in some of the lower income neighborhoods, indeed, the Orca card swipe data is not representative at all, right? So this first kind of check of sort of understanding the inherent biases in the data should be the first thing you do when you're engaging in these analytics projects, as opposed to kind of an afterthought. And that's something that we try to take to heart here in the projects that we take on. Okay. And in fact, I guess hot off the presses here, Mark was showing me earlier today, and I decided to throw it into the talk here. But if you look at Redmond, so people know what's Redmond, who lives in Redmond? Yeah. Okay. All right. So typically, there's a lot of Microsoft employees who live in Redmond, as opposed to Tukwila. The low-income ridership, the boardings here, there's 2% are low-income from Redmond and 12% are Tukwila. So that kind of difference can be pretty substantial in understanding the dynamics. Okay, so you can account for this if you study it, but you have to study it and you have to be aware of these potential biases. Fine. Now that's annoying. There's the logo again. So the Cascadia Urban Analytics Cooperative, this is a $1 million gift from Microsoft joint between University of Washington and UBC. And there's 4 initiatives that we proposed in this space. One is to bootstrap a data science for social good program at UBC and further develop UW's data science for social good program, and hopefully look for opportunities to coordinate between those two. Second, we wanted to foster a sustained joint research efforts in this area of urban data science, where we would tend to try to focus on comparative analytics between the cities. Find something that works in Seattle and try it out in Vancouver, find something that works in Vancouver and try it out in Seattle, and so on, and thereby addressing these issues. I mean, just to give you an example of why this is so challenging, public safety data would be something you'd like to compare between cities, right? How does crime demographics and crime geospatial distribution compare between 2 cities? Well, if you're going to do that, you need to understand that what's called a larceny in one city is called something very different in another city. So the fact that all this data is open and available online, so CRADA, which is a local company here in Seattle, laments about this frequently, where they feel like they've sort of done their job in helping to get all this data open and available online, and yet the usage of it is a little bit less than they would have expected, in part because these data integration challenges are so severe. So instead of shying away from those kind of challenges, we're trying to meet them head on through this program. We're also going to host an undergraduate research symposium highlighting data science for social good in order to get undergraduates lifted up into the research engagement. And then also maybe near and dear to my heart is study some core research challenges in this notion of responsible data science around management, sharing, and analytics of sensitive data. And I'll say a little bit more about what I mean by that. We've heard a couple of times today about the transportation data platform or the trusted data platform. You can swap the T and the C in the P for. We've heard different variations of this right now, but right now the UW Transportation Data Collaborative is both a cloud-based software effort, but also a significant policy effort in this. And Mark, Jan Whittington, here at the University of Washington, and myself are representing University of Washington in this effort. But the idea is, given that we have these cloud services that can manage data at scale and provide these analytics, what we don't yet have is the policy layer on top of that in order to determine who can access what and when. And one of the ways I think about this, and I'll mention something that Jan's interested in this space to give you a character of the kind of problems we're trying to solve. But one of the things I'm interested in is that open data on one end of the spectrum and sorry, this is too sensitive, we can't share it with you on the other end of the spectrum. That's kind of a false dichotomy, right? There's a whole middle space there between those two that if we play the game right and we build the technology out and we think about the sort of algorithms we need for privacy, we can provide access to things but in a managed way, and that's something we're trying to explore with this project. Jan talks about one motivation of her interest. She's done a lot of work on privacy policy. She was one of the architects of the City of Seattle's principles of data sharing principles in order to manage privacy, and this is a continuation of that kind of work. But she mentions that data sets that are available in the city right now are assumed or even asserted to be immune to requests from the public to reveal them. They are sensitive. They tell you private information about citizens. And the idea is, oh, it's okay. If someone were to ask for that under FOIA or any other kind of a request, it would be okay because we could refuse them legally. Well, it turns out if you go talk to the Attorney General of the state of Washington, it's not quite clear that that's the case, that if it were challenged in court, you may have to release that data, and Jan's nervous about that effect. While if you set this up as a third party and use various mechanisms, including things like IP protection that the University of Washington has, including things like human subjects review boards that the University of Washington has, you can tend to protect that data. So there's a very interesting software and technology play here, but also kind of an innovative legal and policy play here in order to try to do social good with this data, provide access to it, but in a managed way. Okay. So that's Data Science for Social Good at the East Science Institute. That's Cascadia Urban Analytics Cooperative. And then scaling up kind of regionally and nationally through the partnership with West Big Data Innovation Hub, there are a couple of these spoke projects that we awarded. NSF awarded several of them last year. In the West, there are two. One is the Metro Insight system being developed at San Diego Supercomputing Center. That's a data management, analytics, and data sharing platform for urban information. Okay. So there's also a real-time kind of data stream component to this, and there's a number of crackerjack computer scientists who are getting interested in this problem as well. So as we sort of see opportunities for these systems emerging, trying to figure out where they can be applied and how to bring them across different cities is one role that the hub can play. And the other project from the hub is less about transportation and more about criminal justice, but there's a planning grant to sort of figure out how to bring big data into this space of criminal justice that we've been pretty excited about. Okay, so for the remaining time, I want to talk about this notion of responsible data science and what I sort of mean by that. My observation is that epistemic issues are beginning to dominate the data science discussion across every field, right? So this is not just, what can we do with these large, noisy, and heterogeneous data sets, but what should we do with them, right? Let's not just keep all data forever just in case we need it, but let's have policies in place to keep it for a limited amount of time and make sure we only use it for what we say we're going to use it for. Apart from sort of the ethical considerations, there's also things like reproducibility, right? Do you actually know what you think you know? Did this result that you threw an algorithm against some data that fell off the back of the truck and you got some kind of result? If you start making actual decisions that affect people's lives based on that and it turns out to be bogus, you've got a problem. So companies, universities, and everybody are starting to realize that the kind of adolescent exuberance around data science is kind of coming to an end, and now we need to sort of mature a little bit and figure out how to think about these issues. Okay, so what does that actually mean, or what are some examples of that? I'll hit my reproducibility point, which several people in the room I think hard about as well. But really across all of science, there's arguably a crisis that people may or may not be aware of. So there's been a couple of studies where, if you attempt to go reproduce cancer studies, only 6 out of 53 were able to be reproduced. Just in 2015, only 50 out of 100 studies in psychology had effect sizes that approximated the original results. There's a pretty famous example with Reinhardt and Rogoff. Have people heard of this? So this is, global economic policy around austerity was based on a couple of spreadsheet errors, where if you missed one country that changed the decision from austerity good to austerity bad, and the paper was published, and there's countries that have implemented this policy on the basis of that paper, and it's wrong. So there's real issues, and you can actually measure this stuff. This is just in clinical medicine, but from 2014 to 2015, there were only 5% more papers published, but there were 37% more retractions over that same period. So people pulling their results back out. So something's going on here. And if you're still not quite convinced, you can just ask scientists directly, do you think there's a reproducibility crisis? And 52% say yes, a significant crisis, and 38% say yes, a slight crisis, and there's a few people that aren't paying attention that say they don't know. So there's something's going on here. And my claim is that there's even a greater risk of these kinds of issues in urban data science for a couple of reasons. One is, the data is much more sensitive, so it's less likely to be transparent, where you may not be allowed to sort of show exactly what you did in all ways, or you may be sort of incentivized to try to hide it a little bit more, to obfuscate things. I think there's a little bit more of a nascent culture of quantitative rigor. I think in clinical medicine, they at least claim to be kind of on the forward edge of frequentist statistics and statistical reasoning. And then I think there's obviously severe political pressures, right? Where if you get the wrong results, somebody's funding could be cut and your agency could be shut down, or somebody could not get elected the next year. So there's really strong incentives to not necessarily always be transparent about that stuff. But it's going to kill us, right? Because as we sort of shift things over to data and algorithms, we're at risk of making really, really big mistakes. Okay. And in fact, there are really big mistakes that are happening nationally and internationally. Are people familiar with this ProPublica article from last May? A few people are, right? So this is recidivism models, right? So there's a company that develops a model that says you plug in all the information about a person who's being accused of a crime, the demographics and their arrest record and all sorts of other information, and hit a button and we'll put out a number that tells you the probability that they're going to recommit a crime. And on the basis of that number, you can decide sentencing. This is legal to do, and the decision to buy this software or not rests in the hands of a fairly low level, in the court system, as opposed to large decisions. One of these models that's quite popular was explored by ProPublica, and it shows that it's demonstrably racist, right? So the model makes a lot of mistakes, but even worse than the fact that it makes so many mistakes. So it correctly predicts recidivism only 61% of the time, which is not the greatest number in the world. But of those, of the remaining percentage when it gets it wrong, if you were labeled higher risk but did not reoffend, you were twice as likely to be African American. And if you were labeled lower risk but you did reoffend, right, so the other kind of error, you were twice as likely to be white, right? So if a human was making decisions like this, they would be fired. But because it's an algorithm, it sort of sanitizes it. Well, the algorithm made me do it, right? Or there must be something true here because the technology said so. So there's something really sort of insidious going on, and our ability to draw these kind of conclusions has outpaced our ability to kind of develop policy around when and how we use those results to make decisions. And just to put another point on this, there's this article that came out, I guess last fall, where there was a hearing. And one of the people who was in charge had a company that was selling these models was answering questions about it. And an African American man stood up and said, "Look, as a black man with an arrest record, should I be afraid of your risk assessment tools?" And they were like, "No, don't worry. You got to tell me a lot more about yourself. At what age were you first arrested, and what is the date of your most recent crime, and all sorts of stuff. And we put all that into the model, so don't worry." And he said, "Yeah, and for example, what is the culture of policing in the neighborhood in which I grew up, right?" So of course I was arrested at a younger age than most people were on average, right? Of course I have a slightly longer arrest record than people there because the police tend to go to those neighborhoods more often. And so these small institutional biases that are there in the data, that's a problem, and we're sort of aware of it, and humans have this too. So it's not to say that algorithms are bad. I mean, I'm a big fan of algorithms as a computer scientist. But the fact that what's insidious to me is that it's this background signal of institutional racism that we know exists gets amplified by the algorithm in that it sort of you start making decisions on it at scale. It gets operationalized by the algorithm in that it's very easy to make decisions now, right? You just plug in a button and go, and your hands are clean. And legitimized by the algorithm, for the same reasons. So we need to be addressing this, and I encourage people that are looking at urban analytics and transportation analytics in particular to think about these issues as a first-class citizen. We heard a mention of the New York City taxi cab data previously. A lot of the emphasis goes on the fact that it got released and you could de-identify it and so forth. My favorite story about this problem was this series of articles, and it's interesting for two reasons. One is it's sort of a subtle use of the data to do something inappropriate, which was, hypothesize that taxi drivers who are Muslim are going to typically be praying 5 times a day at predictable times, and so you could look at their traces and see when they weren't active and therefore predict their religion. That's ugly and terrible, and maybe is a reason not to release the data so willy-nilly. That's fine. Here's what's worse. It doesn't work. This method failed, but it kind of didn't matter, right? It's the fact that blog post is out there instantaneously kind of sends the message to the populace about how data scientists are evil and are doing sort of evil things and so on. It's just the idea that this could be done is out there. So there's really sort of a nuanced discussion we need to have about responsible data science, I'd argue. Okay. And so the way I think about this is I don't want to punt about ludic sort of technology is bad and we need to go back to humans. I just think humans make decisions based on two sources of information, I would claim. One is on past examples, and the other is on some notion of societal constraints. Well, we've gotten very, very, very good at automating the use of past examples to make decisions, right? That's what machine learning is all about. That's what big data is all about. That's what data science is all about. We're great at it. We've only just started to think about how to incorporate societal constraints into those algorithms. But that doesn't mean it's impossible. And in fact, there's a lot of work on, there's a pretty vibrant workshop in the machine learning community called FATML, where FAT stands for Fairness, Accountability, and Transparency in Machine Learning. And so they're looking at how to adapt these algorithms in order to combat algorithmic bias and improve accountability and improve transparency and so on. As a database person, I don't necessarily want to focus on boutique algorithms for boutique applications like the papers that come out there. But what I am interested in is seeing what role can the technology play in this kind of a discussion. If we were to think about a database-like system that could help warn you when you were doing some analysis that may be biased, what might that look like? And so we think things like hypothesis management, better support for data curation, better support for one notion of reusable holdouts, which is if you start rolling the dice 100 times, you're bound to get Yahtzee once, right? You're not really allowed to do that statistically, to sort of keep trying things and trying things and trying things and then getting excited when you find a result. The database is potentially capable of seeing that you're doing that and kind of protecting against that, but they don't do that today. Okay. So fine. So we're looking at systems to do this, and this is the system we're thinking about building for a computer science research problem, but the results from this research will go into things like the trusted data platform, we hope, working with Microsoft. And just to give you one example of the results we have so far, this is just a screenshot of the GitHub page, so fairly useless, but we had this notion of synthesizing fake data in order to help bootstrap collaborations in data science. So what this is the observation that a lot of times the bottleneck to collaboration with city agencies is, everybody around the table is really excited about working together, but in order to get a data sharing agreement in place, that's going to take 18 months, right? And there's just no real way around that. You have to kind of argue about it and get people to feel safe with it and so on. In the meantime, the data scientists aren't really capable of getting started on anything until they actually get their hands dirty with data, right? You have to actually see something. You can't just go to meetings and talk about it. So one thought is, can we take a real data set, run it through a little program, and generate a fake data set that in some sense looks like the real data set, where it looks like certain statistical properties are preserved, but provably doesn't violate any privacy protections. So some of this research had already been worked out in the field of differential privacy, and we took some of those ideas and kind of put it into a tool and released this online, and we're getting started trying to think about how to use this. So this could eventually be a feature of this FIDE system that we're trying to build, which may eventually be a feature of the trusted data platform that we've heard about a couple times today. So this is the kind of direction we're trying to think about doing in order to enable urban analytics kind of at scale across all these fields. So this is my last slide. So the takeaways here, I think, are there's just enormous opportunities in this space of kind of integrative urban analytics. Everything's kind of connected. There's enormous amounts of data coming online. There's a lot of interest in this. Students are excited about it. Everybody's doing this stuff. I think there's organizational challenges in sort of doing the project matchmaking and scaling things to multiple cities. We don't want to get into a space where we're farming out students to do spec work on micro problems around different agencies and never really kind of getting that big impact. And I think we can manage that, but it takes some deliberate thought. And then on the technical side, there's a lot of challenges in working with sensitive data, right? It's Jim Gray, who was a Turing Award-winning database computer scientist, would talk about he loves working with astronomers because the data is worthless, right? And what he meant was, there's no commercial value to it, so you could sort of share it freely and work with it. A lot of us sort of think that way, but you can't sort of put your head in your sand anymore about this. We have to actually understand how to work with the sensitive data if we're going to have real impact on things that matter to people. Well, not to say that astronomy doesn't matter to people, but this is a broad-based interest. Okay, and then I think this open data versus closed data is a false dichotomy. We can do better than that. So I'll stop there, and if there's a couple of minutes for questions, if people want to challenge anything they've heard here or suggest other ideas, or if you have stories that where some of this stuff has reminded you of, I'd love to hear those as well. So thanks very much. It was an abrupt ending. All right, I silenced the room. Thanks.
Thanks, Bill. So we're going to move on to our last activity before the lunch break. And so I'd like to invite up our panelists. The next panel, the topic is transportation collaborations across industry, academia, nonprofits, and the government. Our panel moderator will be Kristen Tufte. She's worked extensively with cross-sector collaborations in the transportation space for the city of Portland. She's the director of Portal, which is a transportation archive, and we're going to hear more about that in her lightning talk this afternoon. She's also an assistant research professor at Portland State University, and I'll give her a chance to actually. Oh, are you gonna sit over there, Kristen?
Oh.
Well, you can if you want. That's fine.
Oh, do you want me to be over there? I can do that.
I want you to be where you want to be. There's an extra spot over there, so if I know it's kind of far away over here. She's apparently a little frightened of her panel. Okay. Thank you.
Okay. All right. Sorry about that. Right. So we have a panel today, transportation collaborations across industry, academia, nonprofits, and government. We have a wonderful group of great panelists. They're diverse perspectives, they're experts, and I think they're hopefully also talkative. So Mamie Marcus, Director of Programs from Challenge Seattle. Steve Barnum, Data Science, City of Seattle. Christine Kendrick, Air Quality Lead and Smart Cities Project Manager from City of Portland. And Mark Hallenbeck, Director of Washington State Transportation Center. So thank you for being panelists today, and I want to thank the panelists particularly for their tolerance of, let's say, my agile approach to the construction of this panel. We're going to talk a little bit about collecting and sharing data, some real-world challenges, tapping into research resources, and what makes a collaboration effective. And then we'll have you out of here in time for lunch by 12:15. Okay, so what I'm going to do to start us off is to ask each panelist to just give us a couple-minute introduction to themselves, and then I have a question about data to kick us off. So go ahead, take it away. You can start. Yeah, go in order.
As you already heard, I'm not shy for talking, so sorry about that. I'm Mark Hallenbeck. You've heard my name used in vain multiple times already this morning, and that's usually the correct way to use my name. So I'm a transportation data scrounge for a living, and I go back long ago in time, so that early on it was about what data could you find in order to possibly provide insight, and now we have the opposite problem. If we have way too much data, how do you actually shrink it down to actually use it in some way, shape, or form? Originally it was a question of, did this little bit of data I have, was it biased because we had so little of it? And now the bigger question, as you heard from Bill Howe, we have these huge data sets, but they still have biases. Do we actually understand what they are so that when we use them, we do something about it? You'll hear a lot about that, but again, I've spent really 35 years pretty much trying to convince people to collect and or share and or use data. And so those problems still exist. They just have very different shapes to the flavor of questions you work with. And you'll hear a little about that when we start to talk about specific panel questions.
Hi, my name is Christine Kendrick. I work for the City of Portland, and I recently made a switch from academia, finishing my PhD in environmental science. I'm an air quality scientist in June of 2016, and then started at the City of Portland in August. There, I work on a variety of air quality projects and also smart cities projects, and some examples of projects that are under that umbrella are an air quality sensor evaluation and Internet of Things pilot funded by NIST, and also creating a new internal smart cities governance structure for the City of Portland so we can work better across bureaus. Through my work at Portland, I am interested in how we can do a better job of data management and data sharing with our existing data sets. So are we sharing and managing data well within our own bureaus, across bureaus, and then also with the public and academia and private sector? And then also, how do we have better data management with all those new data sets that are coming online over the next year? And I also acknowledge that our work, we need to do a better job of data management and sharing is just the first step of turning data into information.
I'm Steve Barham from the city of Seattle, and I'm actually not talkative, so I'll do the best I can.
I'll make it for you. It's okay.
So because I work for the city, I spend about half my time being a data creative, and then the other half trying not to be a bureaucrat. So I work with, we have all kinds of data, congestion, transit, TNCs, car sharing, you name it, I get to work with it. So that's really cool. But I feel like in the next couple of years, most of my time should be working with connected vehicles and autonomous vehicles, because I think that from what I see, that's having the biggest. It's the mode that's changing the most and has the potential to have the biggest impact on a lot of the stuff that I work with. Also say that I love working with Python. Jupyter, there's a Jupyter guy here, and I wish I had Lambda. So if anyone uses those, love to connect with you later. Thanks.
Hello, good morning. My name is that on? My name is Mamie Marcus, and I serve as the Director of Programs for an organization called Challenge Seattle. So I am, by background and training, a economics and public policy geek, and spent the last 10 or so years working in the public sector, both at the King County level and then at the state of Washington. And then about a year ago, I joined this new effort called Challenge Seattle. Some of you may have heard about Challenge Seattle. For those who have not, it's an initiative that got off the ground about 2 years ago. It's a private sector initiative bringing together 17 of the Seattle region's largest employers, private sector employers, and it's led by former Governor Christine Gregoire, who actually will have an opportunity to speak later today at the reception. But Chris Gregoire, for those of you who know her, is a dynamic woman, and she went around the region and brought together these 17 CEOs to work on the major civic issues that are addressing the Seattle region. So the initiative was born out of some data work done by the Boston Consulting Group that took a look at how does Seattle stack up to our other peer cities, both in the United States and internationally. And what are some of the areas where we face challenges to our continued economic vibrancy and to our growth? And out of that emerged a recognition that the private sector in our region could get more involved and lend their expertise, their resources, their minds, their leadership to addressing some of the major issues. So Challenge Seattle is focused in 3 areas. Education, how do we make sure that we are ensuring that the kids in Washington State and Washington students are prepared for the jobs of the future in the Seattle region. Transportation, which is why I am here today joining the panel. How do we make sure that transportation doesn't become a major constraint on our growth as a region? You don't need to spend very much time trying to drive around here before you recognize that transportation has the real possibility of constraining our ability as a region to continue to grow. And then we're also focused on economic development. While the Seattle region is booming right now and we are blessed with that growth, we also recognize that we're a relatively non-diverse economy. 40% of the jobs, either directly or indirectly, trace back to 4 employers in the region: University of Washington, Microsoft, Amazon, and Boeing. And it doesn't, while UW fortunately is not going anywhere, with Amazon and Microsoft in the same sector and Boeing already having a foot in some other parts of our country, the Seattle region needs to make sure that we're fostering an environment that is great for startups and for new innovation and for new businesses and for folks when they're thinking about a new West Coast locale, not to just look at Silicon Valley, but to look at the Seattle region. So I'm here today to talk a little bit about our transportation work, which is largely around how can the private sector work collaboratively with the public sector, with the academic sector, to bring technology to the fore to address our transportation challenges. Thank you.
All right. Okay, thank you, everyone. So I have to say I love that Steve loves Python because Python is a really cool language. So, all right, but since this is sponsored by the West Big Data Hub, let's start with data. And so this question I'm going to target at Mark and let him kick us off. And then I'll ask the other panelists after Mark gives his answer to chime in with your responses also. So Mark, what motivates agencies or private sector companies to collect and share data? And what are some of those challenges we face collecting and sharing that data?
So this is a setup because I'm the one who suggested the question. So the simple answer is your business interest. And you have to realize, since we already talked a little about bias, this is a really biased group of people here, right? You're all interested in big data. You all see huge uses in big data. You all see in your own personal business interest, whether you're as a researcher or whether you're Challenge Seattle or whether you're the city of Portland, the city of Seattle, you see how big data is going to help you. It's in your interest to make this happen. On the other hand, it's not always in the interest to share data. We're wrestling right now with mobility as a service. City of Seattle would love us to do this. Challenge Seattle would like us to succeed, where we want to be able to have you get off the bus, realize that you need to go 2 more miles, and have the Lyft driver ready there to pick you up and whisk you off to where you need to go. And so, of course, we should share between Lyft and transit agencies. Except the last thing Lyft wants to do is to give an open key to where their drivers are picking up and going. And if Lyft does this and gives that data to the city of Seattle so that you can do this, Uber will quickly Freedom of Information Act that, and they will undercut Lyft's prices and steal their drivers. And suddenly this is absolutely suicidal for Lyft to participate. So it's not in Lyft's business interest to share that data. So as you start to deal with sharing of data, you have to understand that all of the different participants have really different views of whether this makes sense or not. We can sit up here and say, absolutely, it's in our interest as a city or a state DOT to share information. But I only have so much budget. And trust me, the data systems always lose in the budget fights. If it comes to improving a data system or paving that street, paving the street always wins. Almost always wins, unless you have a really enlightened agency head who says, no, we have to do this. So in something like the data collaborative that we're working with, one of the key things is we have to understand how this is in your business interest, whether your business interest is making money as Lyft and Uber and private sector companies, whether it's in your business interest as the city of Portland, whether it's in your business interest as Challenge Seattle. How do we make this so that this is a win-win-win-win-win-win-win situation for people to contribute data, contribute money to make the system function, and in order to actually make it beneficial so you get good stuff out of it that costs less than the costs you put into it. And not only that, but your return on investment has to be higher than your other opportunities to use that money. And so in the data sharing world, our biggest problem is making the case why you should participate. To the people in this room, it's obvious, but to the people who aren't in this room, often it's not obvious. And that's a really big challenge. Only when you surmount that, you deal with the data privacy side. That's a huge risk. Risk takes an awful lot of return on investment out of it. Only when you deal with these constraints and get the money, then I get to hire Bill Howe and have him build the system that works, right? But if you don't solve these other parts, the 18 months, a great example, 18 months worth of arguing about how we're allowed to use the data. If you can't solve that, you never get to build the system. And that's all about what's in my business interest to participate. And how do I protect my business interests, however that may be. So that's a really cool but really difficult part of sharing. Once you do it, all these other business things happen. But if you don't survive the first part, the data sharing source never exists. How's that for a downer?
I would also just add one element of thinking about, City of Portland's interest in sharing data is a lot of it's motivated by community engagement. We want to have better government performance, evaluation, but just putting the data out there, raw, unaggregated, large data sets isn't going to help us accomplish that goal. So again, thinking about those interests beforehand, are there other tools we need to add, other agreements that make the data more usable would be important as well.
So just go back to my ORCA data. If I create the ORCA data and I put it out there and I don't tell anybody about the biases and someone, community group, jumps up, grabs this stuff and publishes, as you saw, the great newspaper article about what an awful job we are doing serving somebody, because they did the analytics, they didn't understand the biases in the data set, and they got a really bad answer. And yet, here's my data, I did it, and it's in the Seattle Times, it's on GeekWire, it's on whatever, and now you're spending political capital backpedaling trying to figure out this stuff. And the scariness of that scenario is really obvious to many public officials. And so that causes them hesitation to do this. And so now you have to think through, how do we make sure that people understand this? How do we do the reproducibility? How do we keep people from doing bad things? But again, most of that problem is on the risk side, right? And so having to manage that up front, how do we manage these things so we get the good side and we mitigate the downside? Those are really interesting, difficult questions that are part of the big data hub. And it's very doable, but you have to think about it within the interests of the people and set the data sharing systems up so you get those good parts.
I would just add to that, Mark. I think sometimes it's important to remember that in order to get buy-in from a large group of people, especially those who may not be data scientists, who may be unfamiliar to this, but hold the keys to unlocking that data, is to start with the problem statement that you're trying to solve and be really clear about, you public official have this problem, you private sector folks have this problem. I think we can find a solution to that problem, and then from there, construct what pieces of data do you need to actually solve it. So we found that in working with some of our public sector partners. Take the Washington State Department of Transportation. They have reams and reams and reams and reams and reams of data. And so if you just start with, all right, let's put all the data together and then see what problems we can solve, there's a whole exercise in, first we'd have to do an inventory to understand what data we have. And as many organizations are, that's siloed and different people have different knowledge of what the different data sets are. But if you can start with a clear vision of what is the problem you want to solve, you can quickly prioritize who needs to be involved, what's the data, what are the challenges around that specific data. So I just think that as you're trying to really get the public sector and the private sector engaged, or folks engaged in this problem, defining the problem statement is a great way to get started.
Oh, I was just going to add, I think you really want to challenge the people out there to be really creative with the data that you have as well, because like for your example of Uber and Lyft not providing their data, if they're not going to provide the data, but you still need some sort of information in order to make decisions and manage the transportation system, you have to find it another way. And in order to find it another way, you have to be really creative. You have to infer, and you have to use data science principles. So that's why it's really great to have people like this in the room using the data. And I think when you started with your project, I don't think you necessarily knew sort of what kind of outcomes you would get, right?
You're right. We were in the Orca project. The coolest thing about it was our mission statement was incredibly broad. But we started with the data privacy side. And this is what's been really fun for me working with Bill Howe and Jan Whittington on the Transportation Data Collaborative. The point we started with is the use case. How are you allowed to use this? And in the Orca project, we started with, these are uses you're allowed to do. These are the things you can do and can't do. And then we got to be creative. And so and we didn't get the data in our hands until we had agreed on how it was allowed to be used. And once we had signed off on that, then the creativity came into play. But that data use agreement up front, you can do these things and you can't do those things, has been key to actually starting the project, which allowed the creativity to go forward. And then, I'm laughing with Kristen, we're the iceberg principle. 80% of the iceberg is below the water, and that's all of the data systems. But the things that sell it are the 20% of the iceberg that you can see as you are in the Titanic approaching it, right? And hopefully you turn the ship. I don't always turn the ship very well. That having been said, though, 20% is how you sell. That's the vision you're selling, but you have all this work to be. And then the creativity goes from there. But if you haven't done the groundwork, and the very base of the iceberg is, in fact, the data use policies.
Okay, great. Thank you. I think so what I'm hearing is business case and use cases are critical, and creative uses of the data are critical. I think those are my two big takeaways.
Okay, so I want to just switch. The next topic, I have a couple questions on this topic, but the next topic is really about collaborations and how making these public-private university collaborations effective and produce results that are useful. So I'll target this first one at Mamie, and the question is, what real-world transportation challenges do you see jurisdictions facing, and how do you think we could work together as a community to bring solutions to life? So if Mamie can kick us off, and then I'm sure the other panelists will have thoughts also.
Absolutely. So Challenge Seattle, one of our key values around our work in transportation is that it's going to take innovation and collaboration, and never before seen collaboration. We are all users of the system. We're all part of the problem. We're all part of the solution, therefore. And so you really need to bring together the expertise, the knowledge, the data, the willingness, the political will, the cultural change. All of that needs to come from individual users, from the public sector agencies, from the private sector, from academia. So one of the things Challenge Seattle is doing here in the Seattle region is that we've teamed up with the University of Washington to create something called the Mobility Innovation Center. And the idea is there to actually create a hub where the public sector, private sector, and academia are working together in that collaborative fashion on real-world problems that are affecting the Seattle region. And so we want at UW to tap into all of the disciplines that are working on this issue, because it's not just in engineering anymore. Transportation is in, there's professors working on it in law, in public policy, in transportation, in engineering, in information school, in urban design, et cetera, et cetera, et cetera. So how do you tap into all of that expertise and bring it together with willing partners from the public sector? So that's really key, is you've really got to have public sector leadership that is willing to have that big vision and is willing to say, yeah, there are new and better ways to do this. And then you've got to have support from the private sector, whether it's from Microsoft and Amazon and others offering their tools or their vision or their expertise, or Uber and Lyft offering their data. How can you sort of bring all of that together in one place where these problems can be solved? So one of our challenges is we've got people excited around this idea, and we're trying to figure out, how do we create that pipeline of projects? What are those projects that are that could come to the center and really result in implementation? So for example, we've got a couple projects going right now. One is looking at the I-5 corridor. As you all know, I-5 runs right through the city of Seattle, and occasionally we have crashes and incidents that end up restricting capacity on the I-5 corridor. We had a tanker truck filled with fuel roll over a couple of months ago, and it shut down the highway system for 8 hours. So we are taking a new look at how could we use technology to bring together public and private sector stakeholders to look at, how do you address when things like that happen on I-5? How could you improve the incident response so it went faster? And then how could you also mitigate traffic around the incident? So if the tanker truck is a perfect example. It was going to take so many hours to get that fuel out and get that tanker upright. In the meantime, traffic is piling up in all directions. People are stuck in the city. They can't pick up their kids from school. It was a disaster. And so it's an economic imperative as a region to figure out, how do we get traffic flowing? So we're bringing together on this project a group of researchers from the University of Washington, but we've also got SDOT at the table, Seattle Department of Transportation. We've got the Washington State Department of Transportation. We've got Seattle Police, we've got Seattle Fire, Washington State Patrol, all coming together to think about, okay, how could we do this differently? From low-tech solutions like, oh, I didn't realize that you guys have a detour route for buses that's maybe not aligned with my detour route for roads. Let's compare notes at the sort of low-tech level to the higher-tech level of, how could we do real-time data sharing about where traffic is? How could we push messages out via Waze about detour routes, for example? So that's some of the collaboration that I think can happen when you have different people working together.
And I think going back to our first discussion and what you led with, you have to start with the use cases in order to have that collaboration. So you have a really specific example. And then I think looking at not only just what's the use case, what's the motivation, but what are our current methodologies as a city or State Department of Transportation and how we deal with those and what is and isn't working. So really evaluating that from what methods are in place.
And from the city's perspective, you also have to have within a city, within Seattle at least, and I think it's the same in Portland, you have to have a culture of collaboration, and that comes from the top. So our director of transportation and all the way down and all the way up is very, very keen on giving space for staff to be able to collaborate and meet with people all the time and seek out new partnerships.
Yeah, that culture of collaboration is huge, and especially in this time and age where technology and data are growing rapidly or advancing at a fast pace that government alone can't keep up with it. And so collaborations with researchers and private sector are key to figure out the best way to actually take advantage of those quick changes.
Okay, so collaboration is key, is what I'm hearing, and I would totally agree with that. That's one of my soapboxes. Since we are at a university and we're talking about university researchers, I wonder if the panelists, and maybe Christine can kick us off on this, can talk a little bit about how they think we might best tap into university research, or maybe what are some of the challenges in collaborating with university researchers. Having said that, I am a university researcher who Christine has to collaborate with. So,
no challenges?
There are no, yeah, right.
I think one step that that works really well, at least with City of Portland and Portland State University, is actually having the opportunity to talk about projects before they're implemented. That way we can actually identify, are the methods and indicators that we've set up actually doable? Do we have the ability to collect that data? Do we actually need to add different types of measurement to ensure project success? Maybe the way we're thinking about designing and implementing a project could be tweaked, and that would be feedback we get from talking about researchers before. So we are both getting data that's useful to City of Portland, Portland residents, and transportation researchers. And it might seem like a really obvious step, because I feel like in research, before you embark on any question or project, you are leading with those research questions. You're thinking about your study design. So just making sure we take those steps with city projects as well is really important.
The only thing I would add is one of the challenges we've found is navigating all the good work that's being done at a university. Universities are huge places where there are lots and lots of really interesting work happening and experts in the field. And so it can tend to be very siloed. And so one of the things we're discovering is, oh, so-and-so is working on that project. Is that connected to this? And how is that connected to this? So how do you bring all of that together to sort of what Bill Howe was saying? How do you avoid having a whole set of boutique projects, but really collaborate and collapse that expertise and centralize it so that you can move bigger things forward?
I'll just add one extra twist on some of the things you've already heard, and that's the self-interest of the university is often different than the self-interest of the actual agency. The agency, for the most part, is trying to solve this physical problem of people moving around or vehicles parking somewhere or whatever it may be. University people are often driven to write cool papers, and the last thing they want to do is be responsible for a system that actually keeps functioning after they're done. And so those are actually bigger differences than you might want to admit. So building a system that works now with a data set that you got your hands on and could manipulate and wrote a really cool algorithm, that's a really different problem than writing a business solution that continues to operate for a long time. And that disconnect sometimes causes tension between the universities, which are trying to do cool new research, and the cities who have a limited budget and are trying to build solutions. So finding a common way to go from the initial research to the deployment path, that often needs some extra care and attention as you create the collaborative space in the first place.
And I'll put in a quick plug for the eScience School. We're working with them this summer, and I think one of the things that they're recommending, or one of the deliverables of the project, is actually having published your algorithms on a GitHub or something like that, having clear deliverables that you can build off of, and also collaboration with it within other UW departments. So I think what you're describing, I think the eSchool seems to be sort of on the right track for that.
The eSchool, I'll keep eScience at. They're a wonderfully informed group and forward thinking within much of the university. And that's not just because I'm working with them again this summer.
Okay, thanks. So let me just, I heard let's look at use case first. That's interesting for me to hear Mamie talk about having to learn to navigate the university. From my personal perspective, I'm at a university, so it's been a real learning experience learning to navigate the public sector agencies. And just to second what Mark said on university, people want to write papers and don't necessarily want running systems, and I totally agree that that is a bigger gap than we typically acknowledge. So I think you've all had a chance to discuss collaborations you're working on, and so let's maybe, before we wrap up, how might we scale our successes regionally, nationally, globally? So what are you working on that has been successful or maybe not? And how might that extend to other cities or universities?
Yeah, I always reach for the first, right? That's just welcome to Mark. Sorry.
We should have like a buzzer. And
yes.
the first person who hits the buzzer gets the right.
So the first thing is always people want incentive to do something, right? So the GitHub, how do we share stuff, right? So there has to be an incentive for other people to pick up what you're doing. So standardization in your data formats. Here, please provide data of this kind, shape, or form in this way, shape, or form. And if you do that, you can grab our cool tool, which then anyone can use, right? And whether here you put the data in, and so now you have a real incentive. So my favorite example is actually the Portland example of GTFS, the General Transit Feed Specification. Here is a collaboration between Google, an IT firm, and TriMet, the transit agency. Here's a data format. Now, on how you describe where buses are. But the win-win-win for every transit agency is, look, if you just give us this, Google will place your routes on our map, and then anybody in the world can figure out how to go somewhere within the city of whatever it may be. So here's this huge, cheap incentive. All you have to do is ship us this file, and everybody who uses Google Maps or now Bing Maps or any other map, right, can route themselves on our transit agency. So here's a way where we scaled a little thing internationally by a little bit of standardization and some really cool applications. And so that is one of the great things that big data can do, but only if you have standardization and only if you have central repositories. And big data could be really good at both of those things. And now I have the financial incentive to participate. And once I do that, 7 other developers can build cool things off of my GTFS feed, which they've done. So that's a great opportunity for us to push things forward if we look to have some level of uniform standard with a way to go forward to advance that standard over time and a consistent mechanism where other people can get access, APIs to big data sets, but ways that people can learn about where those APIs are and can use them.
So is your Orca project going to have an API feed?
We'd really like to get there. Absolutely. So the classic data problem, if you look at electronic fare card systems around the country, around the world, they each collect data a little differently, right? And so there's the 80% down low, you're going to have to create the mechanism which gets you to a particular point. Say, all IDs removed, right? So that takes care of the privacy, and you're going to upload here trips, you're going to upload here boardings, you're going to upload here our transfers and the details about transfers, but nothing about IDs. That would be the standardized data layers. Here's 3 particular kinds of data sets you would produce, and maybe a bias flag, right? And a value about the bias flag so someone could know it. Here's my data feed. Now come write cool apps. And now when I engage with students, now that creativity, because there's nothing more creative than young students, right? They come and say, oh, look what I could do with that. And then those things take place. The problem is, now I have to convince the transit agency to do the 80% grunt work to get to that point. So would we like to get there? Yes, but most of our project has really been on the 80% down below and then examples up above. But we would love to have APIs that deal with all our data privacy stuff so that other people could do cool stuff. Yeah, that's definitely the goal we aim at.
Well, and I think one thing that when I think about air quality data and some of the sensor pilots that we're doing in Portland and scaling that up to other cities and regions, you mentioned a bias flag. So it's not just the data standard, the format that the data is coming in, but actually the data quality. How do we note what certain trends have come in when it was recalibrated? And then is another other city that we're going to share this data with and we want to compare values with doing the same exact thing? Or how are they addressing those issues? So also those data quality standards, really important when certain measurements in order to make scalable solutions and not just those boutique solutions.
I think one of the other ways that we will get to scale is that it's an exciting time to be in transportation and at the intersection of technology and transportation. And there are lots of cool experiments happening in cities all around the world. I think things like the Smart Cities Challenge that federal DOT put on, I think is great because it gets that information out there. It gets that idea sharing going. And I think that's one great thing about transportation. It's such a public sector. You have to have the public sector involved, and the public sector is all about, and the academic sector for that matter, is all about sharing information and sharing best practices and sharing lessons learned. I loved hearing about the city of Bellevue and Franz's presentation about how well that first negotiation with Microsoft took 6 months, but we're hoping now that we've worked through all the issues, and now we're happy to share how that contract process worked so that we can streamline it in the future. So I think that as we do these experiments, we will learn what works and what doesn't work. And then to the extent that we can share those lessons, I think that's how you will get to scale.
So in addition to sort of the standardization of the data, I think one thing that would add tremendous value to it would be to be able to get the data in real time. So I think an example of that in Seattle is parking. Everybody wants to take our data and predict where you can find a parking spot. So what's the probability of finding a parking spot? Everyone's trying to build that app, and we're probably going to have like a Kaggle competition or something because there's so many people. But it only works, or it's only valuable if we're publishing that data as it comes in. If we're processing it and we're giving you yesterday's data or last week's data, then it's really not that helpful. So I think it's really something that cities really have. It's not something that's easy for us to do, but I think in order to scale up and outward, I think it's got to be something that we can solve.
But just on parking data, we know how many people paid for parking in real time. What we don't know is the fact that if you have a disabled vehicle placard, you can park without paying. And we don't see that because you're not paying, right? So that's a real problem for us in identifying available parking spaces. Or I have a huge business cost in putting in sensors everywhere people could park, so I could actually use the sensor to tell me whether someone's parked there. So providing a data set that I can give you in real time that doesn't tell you what people really need to know is counterproductive. So again, here's the difference between data and the data you need. It might be the data set you think you need, but it isn't the data set you need unless you understand it. So which is a fascinating problem that the city has wrestled with, particularly in freight loading zones, right? We want people to put black cars park in the freight loading zone because it's available and they're going to sit there for 3 minutes, right? But if you're counting on that to be available and you drive up in your UPS truck, there's somebody sitting there. You can't use it. So capturing the right data and being able to deliver it is sometimes harder than we wish it was.
I expect to see you on the leaderboard, the Kaggle leaderboard.
Yeah. And just along those lines, just because I often say in things like, the reason you fund people like Mark to do the Orca project is because I do it all wrong 3 times, but by the 4th time I got it right, and then you should code that, right? Don't look at my first 3. So we did this great analysis comparing Orca usage versus employer subsidies. And we got this truly counterpredictive or counterintuitive result that free parking at your employer site increased the frequency with which you used your Orca card. And we said, what? That makes no sense. Then we stopped and thought about it and said, well, duh, it's because the denominator in our analysis was Orca card usage. The only thing we're looking at is Orca card usage. And if you have free parking, you don't use the Orca card ever. And so you don't show up in our data set. So if you go in and say, wait a minute, the question we're trying to answer is, did you use it at all? And then split it. Only 17% of people who work at an employer with free parking ever use their Orca card, even though their employer gave it to them for free. Once you do that split, then that 17% use their Orca card a lot more than everybody else does because they're transit fanatics or they don't have a car, and therefore they use their employer card way more often than the person who has a Microsoft card, but goes in and out, but they use it periodically, and hey, every once in a while they take it to the Sounders match. So if you don't understand that the denominator is transit users, if you think it's employees, you get the wrong answer. So if my only data set is about people who park and pay for parking, I may not gather the number of people who are parking but don't pay for parking because it's not in the data set. So understanding your data is really key to getting good answers. And the biggest problem, one of those huge risks that make public agencies go, oh, I can't share this, they'll use it wrong, is because they're afraid that people will grab it and not understand it and say really dumb things. Okay. So that's all involved in the user. What are you signing before you get access, my key to that API? You understand that this is what this says and not that. Now go ahead and use it.
Okay, we're only 1.5 minutes over time. If anybody has a final comment, no? Do people want to ask questions, or do you want us to go to one? Okay.
That's a prepared man.
Yes. Okay, I'll try to keep this question short, but I do think it's important. Alfred Nobel created dynamite. His intention was to revolutionize construction. We all know what dynamite was used for afterwards. The nuclear scientists that developed the Manhattan Project, a few years later they developed Pugwash to take personal responsibility. Now there's 3 forms of data that we could look at in servicing. Data that is open, that is neutral, data that is proprietary, but it's the third one that I'm interested, the one that you know that I'm alluding to, the weaponization of big data. There's 3 cases right now that I can mention that at least a few of you are already aware of. One, the, shall we say, the enlightening observation that the Samsung smart televisions can be hacked because they have instructions that are hard-coded to DNS, where you can actually monitor people in real time. Then there's Burger King with their wonderful little commercial that hacked into Google Home that took over the system. And on a more serious note, Uber. They've already been caught without making accusations. I'm saying this is coming out in the media, that they have been distorting data to their drivers for the company's personal profit, that they have been using data obtained, shall we say, in unusual methods from Lyft to hack their business. This is going to happen. This is happening. This is the weaponization. What kind of responsibilities are people going to have when you generate this data?
As always, Mark reads quickly for the microphone. Sorry about that. To me, that's what you have to put into the data use discussions. So here is the data use that you're allowed to use. Only the people who have signed the data use agreements get access to the data uses. And therefore, in a shared environment, I have a contractual capability of maintaining the use of the data. And if you use that data for things that are outside of the use agreement that you signed, now I have legal recourse to go after you in one way, shape, or form, whether that's financial, whether that's cutting off from the data. That comes back to how you actually structure those requirements. So that in a data sharing system, that data use requirement is so vital up front. in saying, this is how you're allowed to use this is what you're allowed to use it for. If you want access to this data set, these are the terms and conditions to which you agree. And you have to then write those terms and conditions to, in fact, limit the evil activity that could be done with whatever the data sets happen to be. Now, you still have to deal with the creative uses, and that means eventually there are updates to those terms and conditions. And yeah, you have to deal with that. But those are definitely things that come really up front in the data sharing world. It doesn't prevent Lyft from doing bad things with Lyft's own data. That's a different issue. But in the realm of data sharing, the use agreement has to be your key starting point and in many respects your ending point.
Do you want? Yeah, go ahead. Do you have a response? Okay. All right.
I'll just say one. And then there's the robots. They're coming.
So I have an hour-long comedy presentation about automated vehicles. So if you believe the automated vehicle hype, they will save the world. If you look at it in the human behavioral world, if Linda Boyle was here, it's actually the tragedy of the commons and all heck breaks loose, right? And it's a really fun comedy presentation because you can describe both different worlds. So in the data world, we don't know. We could, in fact, be at either end of those spectrums. And the question is putting in place the systems as you go along. And the outcome of my comedy presentation about automated vehicles, it's not about the technology. It's about the policies and regulations that govern the use of the policy. In data, it's the exact same thing. It can be heaven, it can be hell. The opportunities are equal for those two outcomes. And whether you get to heaven or hell is going to be a function of your data use policies. It's going to be about your regulations. And it's going to be about how you allow people to use that information. And that means it's really important for us tech people to get out of the tech world and understand behavior, understand what drives businesses, and look at those underlying social uses of our data. It's a really fun but really big thing.
Okay. All right. And on that note, important for us tech people to get out and understand the social implications of our data. Let me repeat that. I think that's critical. Words I've heard: use cases, business cases, creativity, collaboration, standardization, quality, and sharing lessons learned. And hopefully we've done a bit of that today. So let me just take a moment to thank our panelists for their time and effort today.
Thank you. Yeah, thank you, Kristen. Thank you, panelists. And now, yes, lunch, not provided by us. There's a lot of lunch options in this building, the Husky Union building. So please take advantage of those. You're welcome to bring lunch back in here or find other spots to eat. It's not currently raining, which for us in Seattle is a great day. And so you may want to go outside too. Please do come back. I would say in advance of 1:30. We're going to start 1:30 prompt because we have a bunch of lightning talks about cool tools and demos that people have developed, many of these people in the room with you, that we'd like to hear about. So please try and get back more like 1:20, 1:25, and we'll get going again right at 1:30.
If you don't know the hub, one level down is where all the food is.
Yes.
And if you don't like the food options there are a couple of food trucks in Red Square, which is you just go out the doors and go past the library to Red Square, and there will be, I think there are 2 or 3 food trucks there as well.
Yeah, there.
So those are your food options.
Thank you, Mark, for chiming in on with UW knowledge. Yeah, we can't. If you just want to stay up here through the break, Mark will be answering questions throughout the lunch break.
Yeah, we'll start promptly at 1:30, so try to be back like 1:20. Yeah, if he wants to set it up now, because I'm going to be dealing with live stream people pretty soon, like at the very beginning. So if you want to. I think we should just use the house one. Yeah. I think behind the tables. Yeah, thank you. thing from you. Did you want to send something else?
Yeah.
Okay. You emailed it?
Click on.
Oh, this?
Yeah. It's going to show. What did I ask?
Let me see a ping.
You want to send it?
Oh, there it is. Okay.
You copy and paste that to.
This?
Yeah. To somewhere I can copy paste from.
Just like
You don't want to.
notes.
You want to. You have two screens.
What?
Split the screen.
Split the screen. Hold on, just a second. I don't actually use Max all that much. Is there?
Yeah.
Oh, you mean to have the continuous display? Yeah, we could do that. Yeah, hopefully that doesn't
Now you can
mess
drag
up.
out what you want to show. Remove this.
Yeah, the problem is that.
So I can do that one. You can mute it for now. If there's someone else speaking before us.
Well, yeah, there's a whole bunch of people speaking, and there's
Yeah,
there's
I
a
can do
video
that.
chat that we're doing. So.
Video? Okay.
Yeah.
What does that mean? What
Somebody, the chief analytics officer from New York City, is going to video in, and so we'll show
Okay.
him there.
So,
but
I'll just change this one to our post.
okay, sure.
We paste them on the desktop, the document, the notebook, notes.
I could put this here. Let me add a. Is this a new one? Nope, that's photo. How do you add a new note?
I
New
don't know how to
folder.
do this.
New folder. Oh my gosh, Max.
Probably this.
This one, yeah. New note. Okay. There you go.
And let's do this. So it goes shows the door there.
Yep. Sure. Thanks. Just go ahead and
Just go there
delete
to
that.
see it. Just follow the thing.
This one? Do you care which Firefox, Safari?
Shouldn't matter. Okay.
You're going to log in?
No.
No? You're not going to log in?
I'm just gonna use this.
Oh, okay. Okay. Great.
Oh, sorry. What?
Hey, Katie, it's Meredith. Doing well. How are you? Yeah, we discovered something really sneaky about YouTube that they require you to link an AdSense account to be able to live stream from an external site versus just from their youtube.com site, and they totally changed their policy because we've done it before. Yeah, yeah. I am on the Uber conference link if you want to test and see if we can see you by video. And I don't know if he's going to share a screen or if it's just video, but the audio should be HD. Mhm. Okay. Sure. Okay. Hey, John, I'm testing the video right now. We're testing the video to make sure that the audio goes through the HDMI
Right.
cable.
Well,
So
when you played the video, it
did.
did, so it should work. But again, for anyone to talk to them, they got to be here.
Here, yeah. Okay. Oh, I see you're viewing. Okay. Oh, I see New York dot on the map. Let's try the video. You still there? Katie? Oh, okay. Yeah, I'm gonna try another browser. Let me see. See if the video settings show up. My phone, my computer, view only, 2 other viewers, audio. Maybe there's no video and it's sharing screen. So if he's just doing a chat, maybe I should just send him the link for appear.in. I don't see the video either. Okay, let's test the, let me send you, I'll chat with you. Can I chat something? Here we go. Try going to this, appear.in, and we'll just give that to him. Yeah, you see me? Don't see you. Oh. Okay. Hopefully there's not. Okay. Okay, so I just hung up on you. Can you hear me okay like this?
Mic.
Oh, that's perfect. Okay. We'll just send him this.
Oh, there you are. Okay. I was muted. That helps. Ooh. Oh, that's still open. Oh, I still have the other thing open. There we go. That's better. Okay. Yeah, I think this might work better, especially if you want video.
Okay.
Cool.
Can you? Let's see. Let me find that note for Amen.
Oh, he just replied. Okay, great. I'll just send him that link.
Okay.
Oh wait, no, I shut that window. So I've lost that link. No, I guess it's right there. Perfect. All right, cool. I think that's it then. Good luck. Looks like it's going well. All right, take care.
See you.
Bye.
slides look great. You're set to go number 3. So Amin Ram Mashariki from New York will be doing video, and then Carol Flanagan will be doing video, and then you'll be the first in-person one.
And I assume it's just like one big deck or something.
I've actually got everyone's numbered in order because the formatting didn't really all go cohesively. So I'll just, say your name and your title, and while I'm doing that, I'll upload the slide deck.
Okay.
Yeah.
Great.
Yeah.
Looking forward to it.
So can I be mic'd up actually? So what I thought I'd do is I'll ride around until I get, because it's hard to do this without giving some background about what I'm doing. So until I get to my third slide or something, which is where I talk quickly about instant reporting, I want to defer this. So I'll mic up, I'll ride in, I'll ride around until I can just go back and forth.
Okay. Well, I was going to basically wear this mic so that we'd have to switch unless they have another one.
Oh, okay.
Because I'm going to have to be introducing people back and forth.
So I could give you a script then to talk until the third slide, and then I can just stop there and take over from there.
Sure.
Is that what you?
Yeah. Can you send it to me on my phone?
Yeah.
Okay.
And so you'll talk while I'm writing around.
Hello? Oh, okay. Can we adjust? Okay, that sounds better. Great. The gymnastics are so the chief analytics officer of New York City isn't just looking at me on the wall, but can see all of you guys.
You are the first participant on the call. Please hold while we wait for the others to join.
He's gonna dial in. We're gonna do two different platforms.
Meredith, can you hear me?
Oh, yes.
All right, awesome. Hey.
Are you dialed in through the number or through the appear.in?
Appear.in. I went and stole a headset from someone.
Okay. I will hang up and leave the other conference room then.
Awesome, thank you.
And I can see Carol from Michigan as well, so we've got a little Brady Bunch going on, at least with your name.
Can you hear me also, or? Yes. Okay, great.
We can hear
Great.
both of you great in the whole auditorium. And so at least for Carol's benefit, and I think Amin Rav, you can see.
Yeah, I can see.
Oh, perfect.
Yeah.
So that's not creepy. You can see the
So.
All right, just check in with the crew. Are we live streaming? Yes? Excellent. Okay. So welcome back, everyone, for our afternoon session. Hope you had a good lunch break. To kick off our lightning talks this afternoon, we actually have two awesome remote participants. We have Amin Ra Mashariki, who's the Chief Analytics Officer for the City of New York, as well as Carol Flanagan, who's a Research Associate Professor at the University of Michigan at Ann Arbor. So they're both on the line, audio-wise, and you can see Carol here on the screen. And so if you, Amin, could kick us off in terms of a few minutes on Northeast transportation perspectives, and then we'll hand it over to Carol, and then get all of the folks in person for their live streams lining up by the stage to partake in this new activity.
Excellent. Thank you so much, Meredith. It's a pleasure to be able to engage with you guys. So I'm just going to be very brief. So I'm going to talk from the perspective of some of the things that my office is doing. And what I'm going to do is share screen. Let's see which one. Let me cancel that. And let me take this off. Sorry, a few things happening here at the same time.
Oh, I'm sure you don't have, a lot of things going on in New York City that involve data for you today.
Well, the thing is, but the thing is that I've got three screens, and so it's, all right, here we go. So can you see that Vision Zero map? Awesome. All right, everyone can see that?
I think you can see it. We don't see it yet.
I shared it.
You shared it?
And so it's up at the top left here. It's showing, instead of my name, it's showing the screen. So
You hit share screen?
Yep, I hit share screen. Let's see. Let me do it again.
I see a Mac background. It might be a secondary screen.
Let me see if I'm going to do application window.
Oh, now I see a dark, oh, it's just a different part of that window.
You see?
You want to send the link over to Carol? We can see her. Just kidding.
So it's showing up on the view over there.
You can also email it to me, and I could pull it up for folks.
Yeah, I'm going to email it to you right now. Let's see. All right, Meredith. Come on. Let's send you one other.
Got it. Okay, we've got the Vision Zero.
Okay, and then if you can open up sorry, I didn't send these in the same thing. If you can open up another tab um, and pull that one up. And so we'll call one Vision Zero and we'll call one Building Intelligence Toolkit. And if you can flip back and forth for me. So you got that second one?
Yep, coming right up. But the Vision Zero
Awesome.
one is up already, so.
Awesome. So I'll speak to that. So essentially, what we wanted to do was here in New York City, we've been focusing on a lot of emergency response. And my office has played a particularly central role in sharing data specifically around emergency response. And so one of the things we did during what we refer to, we do these things once a month called data drills, where we bring multiple agencies together and we present situations. And part of those situations, the thing is, those situations require each agency to share data and engage and ask questions of each agency such that agency A can be maximally effective during this emergency response, right? And so what we found that traffic during emergency response is very important, not only to NYPD, FDNY, and so on and so forth. It's important to a lot of agencies, Parks Department, the Department of Buildings, and so on and so forth. And so we worked with Waze, and I know a lot of cities have the Connected Citizen partnership with Waze. But we didn't have one officially, but we reached out to Waze and we asked them to stream some data for us, share some data with us in a stream. And so we took that data. We also took a 3D model of New York City. And then we also took a bunch of data sets that are on the Open Data Portal. My office also has oversight over our Open Data Portal. And we essentially created this dashboard that you see here. So most of this data is from is all open. All of this data is all openly available, except for the Waze data. You have to have a partnership. Some of this data you have to have keys and licenses for, but you can just request that from Department of Transportation or my office. And essentially, if you see at the bottom here, we have all of these indicators around traffic, cameras, collisions, pedestrians, deaths, cyclist deaths. If you scroll over, Meredith, you can see motorists, air quality, and weather as well. Right? And so we stream all of that live, and then you see the moving dots. We get the data from Waze, we clean it up, and then we live stream it to this app such that you can see traffic and traffic speed and so on and so forth. And so what we've allowed to happen here is for agencies to be able to respond smartly to any number of things. Let's say down trees. If there's a down tree, you can kind of get a sense of what the traffic is going there. Also, whether or not that down tree is backing traffic up. And so you can prioritize which down trees to go to based on the impact they're having on traffic and so on and so forth. And so these are sorts of the maps and capabilities that we're building in for smarter traffic overlay. So if you go to, Meredith, if you go to the next tab with the building intelligence, and so the idea there is that while we've built these separately, the idea is to integrate these such that you can also see during emergencies, specifically which buildings in New York City. You'll see, Meredith, can you see the green, red, and yellow sort of designation for the buildings?
Fair and good.
So Department of Buildings and FDNY, after emergencies and during emergencies, go in and tag, they inspect buildings. And on the fly, they can tell you if the condition of a building, damaged, fair, or good. And so we track that real time as well. And when you overlay that, and if you look at the top left, I don't know if many of you can see, but what we've done is we've taken information about a building and stored it here. So if you click on the building, you'll get the year it was built, how many floors, the roof height, building classification, how many complaints, violations, and so on and so forth. If there are elevators there, if there are inspections, all this information about that building. And if you overlay that with the traffic information, you can get a sense of it's easiest for inspectors to go to buildings and inspect buildings based upon traffic pattern and so on and so forth. And so what we've tried to build is this intelligent environment where we get all of this data rolling into what we call the Citywide Intelligence Hub. And once that data is there, then we can expose it. And what you just saw are two maps that we're able to build, not from disparate data sources, but from data sources that all are federated across the city. And so any person in New York City, agency and so on and so forth, can build an app or a map based on all of this data that we have. And so we've really begun to sort of focus on transportation data using Waze data and open data from Department of Transportation to build these sort of smart capabilities for people to be maximally responsive, specifically during emergencies.
Great, and I know the challenge participants will be excited to hear that as part of this challenge, Waze has committed to working with the Big Data Hubs through their Connected Citizens program and facilitating access to their data. And Esri is also in the room and will be giving a lightning talk on some of their capabilities in just a few minutes.
Awesome.
Great.
Thank you so much, Meredith.
Thank you for joining us. I think we'll shoot over to Carol since we have a very full schedule, but we really appreciate you dialing in and representing the Northeast Hub in New York City.
You want me to start?
Yes. You
Okay.
are
You can
on the
hear
big
me?
screen.
I've got 5 minutes, right, or less. So I'm a lead for the transportation spoke for the Midwest Big Data Hub. And I just want to mention a couple of things to this group. We're really excited that you guys are launching the National Transportation Data Challenge. We need, in transportation, we need to do something as fatalities are going up. So the Midwest Big Data Hub is a group of universities involved, and Michigan is one of the collaborators there. And we broadly have a lot of background in mobility, safety. My background is safety data, and especially infrastructure research. And one sort of area that I kind of wanted to mention that's particularly important for the Midwest is trying to figure out how automation, which I believe will in fact help substantially to solve the safety problem, but we have to understand how automation works for Midwest with kind of more spread out cities, more mid-sized cities, large open spaces, that kind of thing. And so that's actually one of the focus areas for an upcoming transportation spoke meeting that will be held on June 22 and 23 here in Ann Arbor. And we'll have several other topics, but that's one we've been thinking about quite a bit. And as part of that, we will be promoting the data challenge. And I'm doing a couple of things towards that. One is I'm trying to help identify and track down data sets. And that's an ongoing effort, and I'll keep working on it. And then at that event, I will also be offering sort of a quick tutorial in what's the data, where's the data, what do you do with the data, that sort of thing, at least, again, primarily from a safety perspective. And then the last thing I want to mention real quick is I wanted to especially point people to the Safety Pilot data set, which is located on the Research Data Exchange that Federal Highway hosts. So do you have that? I can read off the URL, or you can post it.
Yeah, we'll paste it on the shared Google Doc for the team formation session.
Okay, so Safety Pilot is a study that was actually run here, and it is kind of the ultimate in multiple data streams, multiple data sources, and they've got several additional data sources, and it's basically driving data. It's people driving. There's kinematic data, weather data, messages running back and forth between vehicles and infrastructure, all sorts of stuff. And so I think that's a particularly, and it's easy to get at. So I want to kind of point people to that. So anyway, and I think this is a wonderful event, and I'm really pleased to be here for 5 minutes.
Thanks so much for taking the time, and hi to everyone in Michigan.
All
right. Okay, so if Amy from Google could come up, the rest of the talks are all in person, so we did the hardest ones first. I'd like to bring up Amy Unruh, who's the developer relations engineer at Google Cloud Platform. And she's going to tell you a little bit about using Google Cloud Platform for data science.
Thanks. So, I'm in developer relations, and I have worked with the Google Cloud Platform with a focus on machine learning, big data, and analytics. And so I'm going to very briefly try to give a bit of an overview of some of the cloud platform products that are relevant to this challenge. We would love to be involved. Given I just have 5 minutes, I'm mostly going to talk about BigQuery. But I wanted to say just a little bit more generally. So we've been sort of seeing some themes emerge, at least in the morning so far, and some of them relate to fusing or joining across heterogeneous databases, dealing with lots of large-scale data, trying to figure out ways to share data, and also figuring out how to normalize and clean large data sets. Maybe how to do feature generation. You've got very low-level data that's not quite the level at which you want to be dealing with it. And also often dealing with unstructured data, things like pictures and videos, maybe unstructured text that you want to analyze. So there are parts of the cloud platform that are sort of particularly relevant to that stuff. And BigQuery is one of them. So, some other things that I won't really have time to talk about that closely, like cloud data flow, some of the machine learning stuff, the machine learning APIs. And so the sort of the big takeaway while I'm standing up here is if anyone is interested, I'll be around at 3 to give demos and talk about some of this stuff in more detail. And we're committed to being involved with this challenge. So if anyone thinks they might want to explore or play around with using cloud platform stuff, we'll be on the Slack channel, and we can even organize little video chats if you just sort of want to talk about, like, what are your problems, what might you use. So we look forward to doing that. All right, so this sort of gives you a sense, now my remaining 3 minutes, of sort of the range of cloud platform stuff. It's very hard to navigate. You're not supposed to really read that slide. There's sort of a few parts of it, again, that are particularly relevant. And so let me just talk about a couple. So the first one is BigQuery. So this is, you heard a little bit about BigQuery from Will in the panel this morning. This is essentially big data analytics warehouse. It's great for interactively querying very large, like terabyte-sized data sets using a SQL query and getting back answers in seconds. It's great for data exploration, data sharing. There's a large free quota that lets you feel a little more free to explore, I think. And particularly relevant for the data challenge, there are a lot of public data sets that are really relevant. Not only transportation data related, but things like census data, weather data. And actually, just for this challenge, we're bringing 2 new ones online probably next week. Traffic fatalities, and the other one is Department of Transportation traffic flow, I believe. So a lot of public data sets. That's one thing to sort of keep in mind. And BigQuery makes it really easy to join across those public data sets. And here's, I'll speed through this very quickly. Here's just like a kind of fun example. One of them that we have is the New York City city bike data set, What are the city bike trips? Where are the stations? So here's an example of just a few little explorational queries you could do on that data. Where are the popular city bike stations? That query looks like this on the city bike trips data set. You can see it's just sort of regular SQL. What are the city bike routes by gender? To get that information, queries look like this. Again, very straightforward. And 33 million trips actually is very small for BigQuery, which can handle much larger data sets. So it doesn't even break a sweat on that. Okay, and then finally, just to say a little bit about data flow, because data pre-processing is important too. Cloud data flow lets you build pipelines to analyze and process data, both bounded and streaming data. And so this is just one example, just to sort of get your mind around what the kinds of things it can do. That takes a lot of tweet data in, and that's sort of an abstract representation of the pipeline, and does some analysis to figure out, like, what are the common bigrams in the tweets. And then it dumps, and this is the important part, then it dumps all that information into BigQuery. And so you can use that more abstract data. You can think of it as sort of more structured or higher level data than to analyze further. So BigQuery and data flow play very well together. All right, and I'm out of time. Thank you very much.
Thanks, Amy, and we really appreciate Google Cloud's commitment to put those new data sets up. So there is one more tricky demo if the Satori folks could come on down, and the next Lightning Talk speaker, if you could be waiting in the wings, that would be fantastic, so we can get back to time.
All righty, and there'll be two of us. I need some help, and I got to practice my speed talking, so forgive me. I got Frederick helping out. He's actually been at MZ for 5 years and one of the people that are responsible for building the platform. So I'm Vladimir Konevsky. I'm head of business development at MZ. You might know us better from the Game of War and Mobile Strike video games, mobile games. We've been around since 2008 and have built an infrastructure and a platform that supports literally millions and tens of millions of concurrent users at the same time. So literally trillions of events, messages translated in 32 different languages in real time as it happens. So literally 3 weeks ago, we've launched Satori. Is it happening? Whoops. I guess I'll be talking so we can get through this. I was hoping to get the website up and actually walk you through some of the things. So we've actually built a platform. We launched Satori about 3 weeks ago as our live open data platform. And it's really, just think of it as a way to aggregate and coalesce every data feed, open data feed, live data feed in the world, and then be able to query it, search it, parse it in flight, and interact with those events as they happen. So one of the things that I've been hearing from yesterday and today is the lack of actual live data. So if you're talking about a use case such as death prevention or accident prevention, you need to interact with that event as it happens as opposed to trending it and doing an analysis of it after the fact. So we've, in essence, created a platform where at this point, we've subscribed to every data feed, RSS data feed in the world. There's about 9.7 million of them now. Scrolling through this, I believe you're showing the RSS feed, right?
Yeah.
Yeah, where we can actually stop it, query it, figure out what's going on, and if I can search for Trump in Chicago or whatever, I will get the headlines for Trump in Chicago and figure out what I can do with it. We've built a bunch of analytics and or logic layers on top of that in the form of bots and nanobots, where we can actually correlate events, analyze events, visualize events, and actually figure out what's happening and who's doing what, where, why, or why not at a certain point in time as it happens. The obvious use cases for this are smarter city, connected car, logistics, fleet management, fleet optimization, resource optimization, building utility and efficiency programs, right? And so obviously we're here to figure out how we can actually work with the cities and the governments around the world to figure out how we can actually optimize and get access to live data. Because frankly, every CIO and chief data scientist that I've sent emails to at whether it's Boston, New York, Department of Commerce, Department of Transportation, there is no live data feed out there. And if, frankly, the city of Seattle is probably the best example of where they're publishing the 911 calls every 5 minutes. And that is about as live as we get, right? There's a bunch of data feeds that we can get to, but they're not live either. And so how do we then build, let's just say, a mobility platform for any smart city or any smart government without any of that live data? So one of the challenges that I have and that we have is actually creating and aggregating all of that live data around the world. So people can actually build real-time apps like what we just saw from New York City. But imagine if we can actually, if there's an accident, I can automatically deploy emergency services, 3 extra taxis, send out to my mobility app to some guys or the consumers of the app, hey, take this bus instead of this bus, or this train is going to go down, without having somebody to analyze and actually do any of that work. It does it automatically. So being able to interact with that event or that JSON object in flight is something that's very unique. It's very important to realizing the vision of smarter cities or smarter nations or connected cars. And it's very exciting because the response we're getting is pretty amazing because there is that lack of interaction with live data. Are you on the transportation feed yet?
Yeah.
So we have a bunch of feeds. This is literally, we went live and now we have, I believe we've got at least 92 transportation feeds, open feeds from around the world that can filter that by buses in Seattle or bikes in New York and actually start interacting with that data set. You got it? Yeah. So there you go. You can take that and integrate it into your code, into your apps, and actually have your apps integrate with that data set as it happens. And one of our first customers is actually the country of New Zealand, where we are actually the mobility platform for the entire country, where we sort of Uberized the entire, let's just say, consumer interaction with transportation, with their commercial entities, to where, if there's an accident, we do deploy emergency services. They understand how many people are coming in on an airplane, so we know how many taxis to push out there. We know how many people are actually sitting in a chairlift per se, right? So we know how many people are going to go down and how to traffic control in terms of a resort population, right? So all that's pretty exciting. It's all new. We're still figuring a lot of this stuff out. We're relatively new, but it's pretty exciting to where we're coming from. I think that's it. Thank you.
Thank you. Next up is Terry Bills, who is the Global Transportation Industry Manager for Esri, and also a sponsor of our reception. Okay. Oh, you changed my screen. Sorry, just a second there. There we go. All right. Go ahead and start talking. I'll get this up for you.
Perfect, thanks. It's a great honor to be here, and we're very happy to sponsor. See if I can. Which is the control here? What's that? Okay, there we go. All right, so let me start off by talking about some new sources of big data. These are a couple of our partners, Teralytics and SafeGraph. They're both tapping into cellular data to better understand our travel patterns and our mobility. AirSage is another one of our customers. They actually are tapping into about 80% of the cell phones in the United States. And they're actually able to analyze that data, create very rich patterns of travel behavior. We have another partner, City Labs. They're actually able to take AirSage's data, geo-enrich it, and I can actually tell you the very, very detailed demographics of the people that are traveling every street segment in the top 100 cities in the U.S. So you'll notice I can tell you the average income, I can tell you the average age, the trip purpose. So we have really access to a phenomenal amount of information about our driving patterns. Another source of big data, we work with a number of the LiDAR data providers. They actually run these vehicles at about 65 miles an hour down the roadway. It's actually collecting a tremendous amount of data. And in turn, they're able to extract every asset, every feature along the roadway. This particular example comes from Utah DOT. They were actually every rumble strip, every guardrail, every cable barrier, every type of asset that is important from a safety point of view, including the pavement condition and the roughness and friction index of the pavement. Again, critical variables for safety analysis. So in the case of Utah, they're actually able to calculate a safety index based on their crash data, overlay that on top of all of their highway asset information, all of those rumble strips, everything, to begin to understand where they need to invest for their highway safety improvement projects. Whoops. And so there you see actually in the case of Utah, they actually publish their safety data. This is actually open to the public. This is a safety index, so you can actually see all of not just the fatalities, but the severe crashes, so severe injuries. What's the crash rate, the severe crash rate? That's actually made public. We work with a car company in Japan, collects the same information, and that's actually when you are driving in your car and you are now entering into a high crash area, your navigation device on your dash actually tells you that you need to exercise caution, that you're now entering a high crash location. Isn't that kind of where we need to be going as a nation? Again, and if you're a parent that has teenage drivers, wouldn't you want them to know where the high crash street segments were located? Another, obviously, you'll hear a little bit later from the City of LA. We've been very privileged to work with the mayor and with the city in terms of really what we consider the next generation of open data. So it's not just let's throw up a bunch of open data, but it's also let's put the tools, the applications in a way that we can begin to analyze, work with that data, and be much more intelligent about it. But I'll leave that to the City of LA to talk about. So what we would like to do, we'll offer as part of the initiative, we'll offer up free licenses in support of any of the teams and the various hackathons. We also have access to some rather unique safety data sets. So we've actually put together about 5 years of the Federal Highway Administration's highway performance monitoring data. So that includes safety data as well as roadway condition data. And as long as US DOT doesn't mind, we can certainly make that information available. We want to work not just with fatality data, but with all severe crash data. We do have access to several states for the complete state, their crash data. So we can work with those states and with you if you'd like to work with some of the state full crash data. We also have various templates for safety analysis, and we can show you where those are located. And we do work with safety organizations worldwide. We can point you to some rather creative and unique work, safety research worldwide. So we applaud USDOT and the Big Data Hub for organizing this, and we think this is really, there's no better cause than really addressing highway safety. So thank you.
Thanks, Terry. And next up, we have someone from my university, UC Berkeley. Ian Rose is here from Project Jupiter, and we'll be discussing some transportation projects. Take it away, Ian.
All right, thanks for having me here. It's a real pleasure to be here. So I'm here to talk real briefly about Project Jupiter. So the image that I've put up here is not Project Jupiter. It's really a stand-in for the more traditional way of interacting with code, and that is a terminal. So I am in no way trying to disparage terminals. I still use them every day. But it's really a pretty limited way of interacting with software. You pretty much have text going in and then text comes out. And so at Project Jupiter, we wanted to really build a suite of tools for richer, more interactive interaction with your software. And so what we wanted was something that allowed us to include images, rich text, equations, maybe some sound and video, and various UI elements that interact with our software and provide a better way of than sharing those results. The one piece of software that everybody has, which is able to actually render all these things, is a web browser. And so this is the most natural place to host this environment. So what Project is it's a web app, or what Project Jupiter is, the flagship product of it is a free and open source web application called the Notebook, which allows us to render all of these things and then share the results of that analysis. So this is an example calculation that I did last night. I wanted to show something that might be of interest to this particular group. And so what I did was I went to the Seattle Department of Transportation Open Data website, or I think it's just Seattle's Open Data website, and downloaded the data file, the CSV file that had all of the bike collisions from 2010 to 2016. So I downloaded that file, loaded it up into the notebook. This notebook panel is on the right here, and then plotted, let's see, every 20th, just so that it's a little easier to see, every 20th collision from this data set. So the point is that this is about 7 lines of code to read in and then plot up this data. And so it's really fairly painless to start actually doing some analysis and interacting with this data. And again, all of this is free and open source. So that's the sort of interactive computing side of things. The other side of the project is then, well, once you've done this analysis, you'd like to share it. So the other side of the project is how do we make this transparent, and how do we make this reproducible? And so we've worked really hard to make it also a viable publishing platform. So once you have done this analysis, you have some text, you have some equations, you have some, you've got some analysis, and you have maybe some images, and then you want to share it with the world. So we've worked really hard to make it exportable as HTML or as PDFs. This is one example of a study that was a blog post of the eScience Institute's own Jake Vanderplas from a couple years ago, where he analyzed some of Seattle's bike data, again, more bike data, and tried to figure out various correlations with the weather, time of year, time of day. It's a really nice piece of work. And then he published the whole thing as a blog post with all of the code and analysis that it took to make the thing. So we think it's a useful set of tools. I think maybe, hopefully, lots of other people here will find it a useful set of tools. And the last thing I wanted to mention is that because it lives in the web browser, the compute engine doesn't need to be in the same place as where you are sitting at the moment. So one thing that's really exciting to us is that lots of cloud compute providers have made Jupyter clients available to their users. And so I should have included Google up here as well, but basically AWS, Azure, and Google all provide Jupyter notebooks for their compute services. So as soon as you need something a bit more beefy than your laptop, there's a smooth transition to that. So with that, thanks for having me.
Thank you. Thanks, Ian. And the hubs are looking forward to participating in the first JupyterCon in August in New York City. Next up, we have Shankari, who's from UC Berkeley. She said she wanted to make a very dramatic entrance, so that's your afternoon entrance. Shankari is a graduate student working with David Culler at UC Berkeley at the Real-Time Intelligent Secure Executions Lab.
Hi, my name is Shankari, and I'm here to talk about my project, which the name of the project is Emission, and what it is it's a mobility scope. What's a mobility scope? I'm not going to go into the details because I only have 5 minutes, but the big difference between a lot of the work you've heard about before and what Emission does is it allows you to talk to people. If you remember, Meredith was here, and she was a person, and I was riding my bike, and I was a person. And while there's a lot of work around instrumenting vehicles, there isn't as much work around instrumenting people. Although everyone, the people who are actually moving are people. So basically, you can use existing data sets, and they're great. But Emission allows you to collect new data from people as well, the data that you really want, as opposed to figuring out things from data that you have. I have 3 slides on what it can do. If you're interested, you can come talk to me. It can collect background travel patterns automatically and categorize them by mode, so you can figure out whether you're walking, biking, or motorized mode. We also allow you to crowdsource near-miss reports, so you heard a lot about why near-miss reports are important earlier. The Bellevue people are working on a vision-based approach, and this is a crowdsourced approach. So if this were on a real street, then when Meredith was standing here and almost got hit by me, she could have actually reported this at the end, and then we could aggregate it and make it available as a set of all of the incident reports that have been collected, as well as the counts of where people actually went from the background data. And both of these are available via a public aggregated API. And the app is integrated with a game to motivate people to use it or to change their behavior or to report incidents. I don't know if a lot of the other projects have talked about what their source policy is, but this is an open source project, which means you can extend it. You can actually go in and change the way things work. So Meredith suggested that I actually have some calls to action to make it fairly clear where we could use improvement. But this is by no means an exhaustive list. There are lots of things you can do with this, where you can change things and install it on people's phones and get the data that you want. Some of the things that I would like to see are, right now you can report incidents at the end of a trip, but it would be great to be able to report it while it happens, so you don't have to remember to go back and click on it and report it. So it would be great if you could shake or tap to report. It would be great if we could actually get some more data about the crowdsourced reporting. Right now, there's just a smiley face or frowny face. Whoa, okay. It would also be great if we could craft a real game it's fine, I can do it. It could also be great if we could actually craft a real game that would motivate people to either change their behavior or report things. So far, we've done an integration, and you can do pointification, where you can give points and badges and so on. But there's been a lot of research that's shown that that's not enough. I mean, points are great, and maybe for a month or something like that. But if you want to really engage people, you have to figure out how to actually make a game around it. And so if you're more interested in the people part than the techno-weenie part, then this is a place where you can really contribute. You can convert the heat maps into actual metrics like counts and speeds and directions and so on. And finally, it would be great if you could think about a way to take all of this crowdsourced data and identify the top 5 or top 10 hotspots that a city should fix in order to meet its Vision Zero goals. Thank you.
Thanks, Shankari. And next up is Nick Bolton from UW, University of Washington. I should clarify, since we have University of Wyoming coming up next. I'm not usually a Mac person. Let me see if I can do window complete or something. Full screen. There you go. And he'll be talking about access map and open sidewalks that was mentioned by Bill Howe earlier.
Cool, great, thank you. Okay, so I'm going to tell you a
about something a little bit different from some of the other speakers. So it's going to be mostly about data that, for the most part, is not there, but should be, and our projects for how to get it. And so I'm going to talk about the general problem of the pedestrian transportation network, as well as two projects that we work on, one called Access Map, the other called Open Sidewalks. So the organizing idea here is that we need a pedestrian transportation network, not just on the ground, because we know there is one out there, but how to represent it with data. Because for the most part, nobody cares about the pedestrian transportation network, at least so far as providing data goes. And so if you look over here on the very, very left, what am I talking about by transportation network? Well, that means we have places that you can go that are connected together. And to make it actually useful, we need to say, this particular location has these features that may impact mobility. So for streets, that might be how long is the street or how busy is the traffic. If you put those two things together, you can do things like routing end-to-end using Google Maps or any kind of transportation provider like that. You can do the analytics that you've seen in the past talks. They all require a transportation network description. And this, for the most part, does not exist for pedestrians because we have a very street-centric transportation network as far as data is concerned. Who benefits from having a pedestrian transportation network? Well, of course, everybody benefits because everybody at some point is using that infrastructure. But the biggest place where we can make a change is for people who have limited mobility. So anywhere between 10 to 20% of the population around the world, but also in the US, has some form of a mobility impairment, which can be something like using a wheelchair, using crutches, using scooters, or just having difficulty walking up very steep areas. So this is a very large part of the population that is not really served by Google Maps because we don't have this pedestrian information. If you don't know where a curb ramp is, you can get stranded on a sidewalk. If you don't know if there's a giant tree root blocking a sidewalk, you might try to go use it and become stuck. And so just as a quick comparison, cars, there's not really much of it, or I guess the reason for this comparison is to explain to some degree why we have a car-centric transportation network and why we don't have a pedestrian one and where we might want to be able to go. So for cars, of course, there's a large amount of money and efficiency and questions that we want to resolve using that transportation network. One of the conveniences is that access to the street is pretty simple for cars. Pretty much all of them can get onto the street and keep going. This is not the case for pedestrians for the most part, because there are so many different requirements. There are people who are blind users who need to use the pedestrian transportation network in a very different way than people who are sighted. Or people who use wheelchairs have a very different requirement from people who are just going to be walking around, which is also different from people who are using powered wheelchairs, who have actually very different and sometimes contradictory requirements for the other groups. And in the future, that will, of course, continue to be the same, diverse requirements. The data that's currently available for streets, I gotta hurry up. All right, I'm just gonna summarize this and say the data's not there for pedestrians for the most part, but we want to get there. So the first project I'll talk about very quickly is Access Map. Access Map, you can consider it to be something like Google Maps, but for pedestrians with a focus on accessibility. This initially came about through a hackathon, but has been enhanced several times through the UW eScience Institute Data Science for Social Good projects, and has been taken on by the Tasker Center with UW CSE. And the basic idea is to create that transportation network where data normally doesn't exist. Right now, it's based on Seattle DOT open data. It took extreme amounts of data fixing and also data creation automatically in order to make that happen. But as a result of combining those pieces of data, we can now do routing for people who use wheelchairs, for example, to show them an actually useful route for them. So on the right, you can see a route. It is not the shortest path, but it is an accessible route that you could use in downtown Seattle. And this motivated the second project, Open Sidewalks. This one is actually focused on the data. The question is, how do you get this data when it doesn't exist already, or doesn't exist in a format that you can actually use to describe a transportation network? And to solve and to address this problem, we chose to use OpenStreetMap as our primary base for data. This is a data commons that is very different from the other data sources we've talked about today because it allows users to contribute data as well. It is a much more democratized version of these systems. And as a result, it has worldwide coverage. So it does scale up, it does have very big data, and it brings with it the ability to contribute data as well and to communicate back and forth between very, very different stakeholders. And so that project involved creating a standardized schema for how to describe these kinds of infrastructures and methods for importing data to say, we have this SDOT data, it's not in the right format, but here's how we can get there. Cool. And if I have time, can I do a quick demo? Do I not have time?
Demos at the coffee break.
Demos at coffee break. Okay, great. Thank you.
I've been told that our closed captioning cuts off, and so we want to try to get everybody in there, but I'm sure that you'll be able to see a great demo from Nick soon. Next, we have Ali Ghazemzadeh, who's a PhD candidate at the University of Wyoming, and he's here to talk about research to deployment using SHARP2 safety data.
Hello, everyone. So today I'm going to talk about the driver performance and behavior in adverse weather conditions using the SHARP2 naturalistic driving study. I would like to thank our team, specifically Dr. Mohammed Ahmed, my advisor, for his unlimited support and guidance. So among the 8 IAP projects, University of Wyoming is the only university working exclusively on weather information and weather-related trips and drivers' behavior and performance in adverse weather conditions. So let us start with this question. Why is it important to understand driver behavior? Transportation researchers have many important findings, and sometimes they require basically society involvement, starting a behavior, stopping a behavior, changing a behavior. Most of the time they don't succeed, and to me this is because they don't use the right language. Using the naturalistic driving data can help us to better understand the driver behavior so as to use the right language. Let us look at the current situation, which to me is like a war situation. Every year millions of us lost their life and are killed and injured in car crashes. Specifically in US, we have more than 30,000 people fatalities every year. The role of weather, what's the role of weather-related crashes? We know that about 25% of crashes are weather-related. Adverse weather conditions can impact the roadways by influencing the surface conditions, driver behavior, vehicle performance, and visibility. And this research, the one that we are working on, is kind of different from other naturalistic driving studies, and I'm going to talk more about that. The picture that you can see here is the I-80 that we had a pileup crash in 2015, and we have a VSL system in this corridor, basically, and we are going to incorporate the results from the SHARP2 project into final countermeasure, which is updating the current weather-based VSL system, and not only that, providing information for advanced traveler information system. The other aspect that we can use the results from this project is we can get more insight into connected vehicle weather application. So just a quick talk about the SHARP2 project. It has 2 main components. RID, which is roadway information database, contains the roadway characteristics of the traveled routes. NDS, which is the naturalistic driving data, 3,500 participants were participating in this project. So if you have a specific driver traveled in a specific route, you can get the basically roadway information of the traversed routes using the RID. Our main research questions are here, and the first research question is that can we really identify the weather-related trips using the 5 petabytes of data? And that's why I mentioned our project is kind of different from other naturalistic driving studies, because the weather information is not provided by default in the naturalistic driving data. So we had to come up with our own methodologies to identify the weather-related trips. If we succeed on that, we can actually work on those trips. By tracking those trips, we can better understand the driver's behavior in adverse weather conditions, and we can basically find the best technique to find the results we are looking for. So for the first phase of this project, we just focused on rain. We requested 50 trips in only rain weather conditions. In phase 2, we focused on all the weather conditions, and in phase 1, we requested another 100 matching trips. When I'm saying matching, it means the same driver, same route, and same vehicle. We faced with lots of challenges for data acquisition and preparation, and I think I don't have time to talk about those. The lesson learned from here, it's challenging to identify and track the weather-related trips, but it's doable. And there is significant difference between drivers' behavior and performance in adverse weather and clear weather conditions. So these are the list of publications that if you're interested, you can go and just check them out. The most recent one, the driver's lane keeping ability in inclement weather conditions. And also, I would be happy to answer your questions via email. So my email is down there. Thank you very much.
Great, and next we have a no slides person, so this should be quite efficient. We have Kristen Tupty up here again. As you will recall from the morning, Kristen is a research assistant professor at Portland State University. She's also on the steering committee for the West Big Data Innovation Hub. You just get this beautiful background.
I have a beautiful background. All right, thanks, Meredith, and thank you for having me here. So I'm going to talk to you today about two quick things. So one is Portal, which is a transportation data archive that I direct. And I think it's of interest to this crowd because it has a really incredible source of data. And the second thing I want to talk about is, oh, am I messing up my...
I can hold this for
No,
you.
I got it.
Computers on computers can be difficult.
Right, you know, like technical difficulties from the people with PhDs in computer science. That's always fun. Okay, so Portal, which is a transportation data archive that I direct, and Smart Cities, because I think Smart Cities is a really interesting source of application and use cases for this data. So first of all, Portal. So Portal is a transportation data archive that was started in 2004, and I've been working on it since about 2005. So we have over 12 years of transportation-related data. We get freeway vehicle counts and speeds, travel times, data from traffic signals, some bicycle counts, information about who gets on the bus, how often they get on the bus and off, vehicle length data, wide variety of data sources. In terms of data from intelligent transportation systems, we have a sample of almost all of those types of data. And actually, many of them actually come into our archive in terms of live streams. I have to say that the archive is generally open. I'm from Portland. We believe in open data, and really got to give a shout out to my colleagues in Portland. This morning we had Portland's new open data policy was approved unanimously by our city council this morning, so we're super excited. The other thing I wanted to talk about is smart cities. And people who know me know that I love smart cities, and I'm obsessed with smart cities. And so what is smart cities? And when I think about smart cities, to me, if you come to Portland, downtown Portland has a beautiful bridge. It has bike lanes. It has bike share. It has plentiful transit service. If you go east Portland, there are few, if any, bike lanes. The crosswalks are few and far between. The transit service has not kept up with growth. And you are approximately 2 times more likely to be hit or killed by a car in East Portland than you are in downtown Portland. This, to me, is not okay. And so to me, smart cities is about how do we use data and technology to bridge the gap between those two different Portlands. And how might we do so? It's really interesting. I was listening to Dan talk this morning about intersection design, and that actually is one of my examples and what I was going to talk about also. So the question is, when you look at an intersection, we want to understand how the intersection functions. How are the pedestrians crossing against the light or with the light? What are the demographics? Are they older? Older people walk slower and they need different intersection designs. So understanding how an intersection functions is critical. Technical challenges. 1, this is an enormous data integration problem, or whatever words you want to call, but combining varied data sets together. It's tough. To the data management folks out there, I would love to see a data integration system that could handle a transportation intersection. Another key challenge is pedestrian data. We know where the cars are. We kind of know where the bikes are. We don't know where the pedestrians are. So technology that uses cameras or any other technology that helps us understand where the pedestrians are and how they move is critical. Another thing I would love to see work on. Okay, so in conclusion, 1, lots of cool data. 2, I talked about intersections and safety as a use case, tons of other interesting stuff too, connected automated vehicles. And I would urge you, as you work in this use case and in this data challenge, think about who is your user? Who is that person you are actually going to help? Thank you.
Thanks, Kristen. Next up, we have Steve Barham from the City of Seattle. You'll remember that he was also on this morning's agenda as a panelist, and he will be discussing S-Dot collision and street data.
Thank you. So I'm mostly here to plug the City of Seattle as a potential collaboration partner, and we have lots of data. I like to think of data in terms of food, and this is what our data looks like. It's beautiful, it's clean, it's colorful, it's perfectly arrayed, it has no errors, and we have 9 nines. So I'm going to show you, well, we probably only have 8 nines. This is one of our data sets. This is from a GIS layer, and we've got, it's more than just the shapefile that we include on those. Like we have speed limit, surface width, slope. We also have things like pavement condition, all types of things that you could use to build your app or to run your deep learning. I'll show you a, we also have a data set on collisions. And so this is just a snapshot of that shows, you can categorize them by the different severity of the collision, when, where, was it sunny, was it raining, was there a lot of light, was the driver distracted, does it involve bikes and peds? And so if you go to our Socrata Open Data Platform, we've got this just sitting there, and I think it gets updated regularly. Our other data sets are on GIS, they're on our website. I've also got a bunch of stuff listed on a document, which I think, is that going to be in the repo?
Yes.
Yes, so check that out. I've got copies over there as well, and come and find me, but I'd love to work with you. And we have great data, 9 nines, so thank you.
I like this data food analogy. Excellent. So next up, we have somebody who might be familiar to the folks who went to the Lunch and Learn at AWS. Jed Sunwall is here to discuss democratizing access to planetary scale data. And between that and Project Jupiter, these lightning talks are out of this world.
Thank you very much. So thank you, everybody. Thanks for sticking around through all these talks. So yeah, my name is Jed Sunwall. I work at AWS. I'm based here in Seattle, and I run our open data program. And what we do with open data on AWS is we like to think about how to make more data more accessible to more people. And one thing that we've found at AWS is that we have a lot of customers that use AWS, entrepreneurs, researchers, and businesses. A lot of them are very greedy for data. They'll take as much data as they can get, and making data available in the cloud can make it much, much more accessible to them and easier for them to work with. And so there's this quote that I like. I shared this yesterday for those of you that came out to our training. But this notion that 80% of a data scientist's time is spent just preparing data for analysis is really a travesty as far as we can see. And we see that as an opportunity to help people. We have a phrase that we use a lot at Amazon to describe these 80% problems. You know, basically like, what are the things in people's lives that are keeping them from doing what they're actually good at and what they actually want to focus on? We call that undifferentiated heavy lifting. And so in our program, we like to think about what are all the chores that people have to go through when they're trying to acquire and work with data that's keeping them from actually getting to work and doing the analysis they want to do. And in fact, we know that there are a lot of people that have questions that they would like to ask and research they'd like to do. They just don't do it because it's such a pain to get data in the first place. And so that's the kind of stuff that we're trying to eliminate. That's cool, this slide. I don't know what happened there. So anyhow, one way that we think about this is just saying, like, how can we make free data cheaper, right? There's all day today we've been talking about open data sources and remarkable data resources that are available to people, but what is the actual cost of getting that data and working with it in terms of people's time and the energy they need to put into getting it useful? So making free data cheaper is kind of a clever way to think about this. Now, relevant to this community and this challenge, we have a very large focus in our program on Earth data that includes weather observations and all sorts of Earth observations, but also includes really any kind of geospatial data. And in fact, recently we announced that there's OpenStreetMap data available in ORC format, which is a columnar data format that is available for people to query really, really rapidly using services like Presto or a managed Presto service that we have called Amazon Athena. But really, these are data files that are available for anybody to use using whatever tools they want in the cloud. And we've made OpenStreetMap available that way, which makes it extremely easy with just a few lines of code to find, for instance, all the hospitals and clinics in, I forgot what country that is, Guinea, Sierra Leone, and Liberia. Now, in support of this challenge, we have teamed up with datascience.com, who you're going to hear from in a minute. So this is, I'm just sort of setting them up, to make more transportation data available in the cloud for people to analyze in the cloud using whatever tools and services they want. Also providing access to the datascience.com platform for people to analyze it very quickly and easily. And then we also have an AWS research credits program. So if you're students or researchers and you have ideas of something that you would like to do, we do provide AWS credits to support your project. We just want to know what you're doing. So if you go to aws.amazon.com/earth/research-credits, you can fill out an application there and let us know what you're working on, and we can provide AWS credits to support your research. So thank you very much. It's an honor to be here and to support this challenge. Thanks.
Excellent. Thank you, Jed. Really exciting announcements and partnership with our friends at Data Science Inc. Speaking of, next up is Dave Goodsmith, who has been a great collaborator with all things data science storytelling, data science training, and so forth. Oh, no, not that one. You're okay to go without slides, right, Dave? Okay. Come on down. I'm trying to find it. I asked Dave for 3 slides, and he was very prepared and gave me 30. And my computer seems to have decided that it wanted to edit that. Oh, here it is, full deck. There you go.
So I've got 30 slides. Probably won't get through them right now, so if anybody wants to see the slide deck, just let me know. It's dave@datascience.com. So start my timer. Number 1 cause of death for children in Los Angeles. Anybody want to take a guess? Traffic accidents, very good. Number 1 preventable cause of death for children in Los Angeles. Yeah. So, that's why I'm here. That story is why Vision Zero exists, and why transportation, beyond all of the economic implications that it has, is a resonant issue at the national, local, individual level. To lighten the mood or get your attention, if I don't have it, I found this in the dumpster, and this is, you see what this is, so just keep an eye on me, see what I'm going to do with this, kind of as a model for all you guys.
Keeping the live stream interesting, Dave.
So briefly, paraphrase RFK, data science is really, really messy. The actual quote is democracy is messy. That unification there is why we're all here with a national challenge, trying to help our communities and our country together to get a grip on what's going on with data science. Specifically, what data science provides is it's a Jupyter-based, also Zeppelin-based. It's the web browser. That's this unifying factor here. We're just going to help with the site, bigdatahubs.io,
to surface everything that you guys are working on to anybody else who would be interested. You have a soapbox here. You have a national platform. You have these regional platforms. Use it. I think about a quarter of you are already taking a leadership position in this challenge. Probably another quarter has talked to Meredith or myself. It's the other 50% of you. You should email Meredith or me with how you will take a leadership role over the next few months before we email you. Certainly before I email you, those of you that haven't met me. Figure that out. That's my ask. Figure out what your leadership role will be. Your careers are fine. You're in the data science field. You have the time. Take a leadership role. Take that next little step, and let us know how you're going to lead. The platform, like I said, it's Jupyter-based. Big Data Hubs.io. We're just going to surface those demos, and wow, that's it. I have extra time. So, the toothbrush. Now I'll use one briefly. The toothbrush is like, let's all use each other's toothbrushes, right? Nobody loves standards, like Dan was saying, right? But like nobody wants to share. Standards are something that everybody needs, but nobody wants to share. Life is short. Things are moving really quickly. Let's share each other's toothbrushes at the least. So that's all. Thanks.
Dave, I see those acting classes in LA are doing you well. I'm not part of that toothbrush sharing demo, at least this time. But thank you for those comments and exciting announcement with Amazon. Next up, we have Corey Marshall, who is in from the Bay Area. He's the Splunk for Good director at Splunk, and he will be sharing a little bit about Splunk and transportation data. Take it away, Corey.
Thank you very much. I'm not sure how I'm supposed to follow that, to be honest with you. No props or anything. But I can start the conversation asking the question that everybody asks me anytime I talk to a group, which is, what is Splunk? And I can start to talk a little bit about that. I'm going to fast forward through those because they're the required slide from our legal team. So what Splunk is all about is making machine data accessible, usable, and valuable to everyone. And this takes a number of different forms. We've got a lot of different customers around the world that you'll recognize, but this is the core of what it is that we do. We take data from every system, network, device, anything you can possibly imagine that spits off data is the type of information that we consume. We do this for companies for a variety of different types of use cases, but what we do is we help them establish the correlations and the patterns between all of those different disparate data sources. And there's been a number of folks that have been talking about the difficulty in trying to normalize data, aggregate data sources, try to establish the correlations and patterns between those. That's something that Splunk does very, very well. And we do it for a variety of different reasons. We got our start doing application delivery and IT operations, do a lot more work around security these days, but lately we've been branching out much more intentionally into the Internet of Things and industrial data, which is the most applicable here. Now, my background is in and around the public sector. So I've always done work with data, but I've done a lot of work with transit and transportation data in the past. I worked for the MTA in San Francisco, worked for the city of Chicago for a number of years. And so this was a real game changer for me because I suddenly realized that there were tools out there that we could start to make use of this. And this is what I get to do. I get to work at Splunk and help change the world. Now, how do we do that? We do research partnerships with research and universities organizations, and we have a large product donation program that is open to everybody that's in this room that is either a researcher, a nonprofit organization, or a student at an educational institution. We have good integration with our good friends over at Amazon. In fact, we're available in their store that you can take advantage of that. And we do a lot of different types of projects that try to have an impact in the world. Now, one of those is with an international humanitarian organization called NetHope. Another was around Hurricane Sandy and the response that was done there. We've done some great proofs of concept with our friends at Amazon. But what I want to talk about right now is what we're going to be doing around NHTSA, fatality data, and how we're going to use that as a foundation for the next steps in our latest project. And so we're going to use that as the foundation, and we're actually going to layer things like weather on top of it. We're going to layer the local transportation data. We're going to layer all those different things in there and start to assemble a really amazing tableau of what an urban system can look like. Now, we got our start, analyzing data systems and networks and things like that, but the most compelling system for me is the urban system. And so I want to get a much better understanding as to how we can apply these types of industrial-grade technologies to these types of very impactful use cases. Now, we had a couple of examples that were talked about. What are the leading causes of preventable fatalities in Los Angeles? Well, with some of these unified data sources, we actually have the ability to do that across cities. And to the extent that we can get access to the data, we can also start to do comparisons across a number of other types of service areas that directly impact that, whether it's transit data, whether it's ITS coming off traffic signals, whether it's bike share data, all those different types of things. I would love to work with any and all of you, honestly, to try to identify what the right combination of those data sources are so that we can start to put them together and identify where those patterns exist. I'm more than happy to work with anybody and everybody in the room. We've got great engineering resources. You can reach me at splunkforgood@splunk.com. Thanks.
Great, thanks, Corey. And it's exciting to have you join, especially since you've been involved with the Hub since the very first charrette, predating myself and some others on our leadership team. And last but not least, we have Jane Zanzig, who's flown in all the way from Chicago. Jane is a data science fellow at the University of Chicago, the Center for Data Science and Public Policy, and she will be speaking about data science for social good and public policy learning resources. This is a twofer. She represents the last lightning talk and the first introduction to our challenge topics.
Right.
Please, Jane.
Thanks. I actually am a UW alum, so go Dogs. And I participated in a study. I was a research subject in one of the studies in Linda's lab where I sat in the driving simulator and pretended to text while I was driving. So, fun fact to begin. Talking about the Data Science for Social Good Summer Fellowship, that's how I got involved with the University of Chicago. It's been over the past 4 years, we bring 10 or 12 teams of 3 to 4 people, usually graduate students in computer science, stats, which is what I was from, social science, and have them work on a project that's a real project with real data with a government organization or a nonprofit. And so over the past 4 years, we've worked with all of these different partners, and it's both a learning experience for the students, the fellows, to learn what it's like to actually use real data and be doing something useful, to get out of the tech world, and for the project partners to learn what does a data science project involve, and what resources do they need to use their data to do whatever they care about. And one of the main things that's really important is the project scoping aspect. So when you ask one of these people at these organizations a lot of time, what data do you collect and what things do you really care about, those things don't match up a lot of time. Like they're not even collecting data about what they want to know about. So that is often, along with the data munging ETL stuff, takes up at least 80% of the time in any of these projects. But we see that these are a few examples of projects that we've worked on in the past and currently. Can I detect who's going to get lead poisoning before it happens? So in the past in the city of Chicago, the only way that you would know that a child was lead poisoned or was at risk for getting lead poisoning was that they already had it, because they would get a blood test and find out they already were affected by lead poisoning. So can we do that predictably so we know before it happens so we can get lead remediation in their homes before they are already poisoned and it's too late? Can I determine which home inspections to prioritize. So right now, working with the city of San Jose to look at which apartment buildings and homes they should go inspect that aren't keeping their places safe for renters. How do I improve the scheduling and assignment of ambulances? So that's more applicable to the transportation field. Where should you send ambulances and when? Can you optimize these types of resources? And then, can I route citizen requests more efficiently and effectively? And that was a project with the Mexican government. They would get all of these requests as emails, and they needed to be able to sort, do we send this to, which agency do we send this to? Do we send it to a human? Should we reject it if it's not real? And then we find through doing all these projects that a lot of times there's sort of a format that all of them kind of fit into. So these are really common as you're trying to come up with a project from, when you're saying we want to do a data science project, these are kind of things categories that your projects will often fall into. And then next, we had some weird stuff happen with these slides too. Oh, there's a little animation. Okay, so why isn't more of this work happening? The things that you need are education and training. So that's what I'm talking about today, is the curriculum resources that we've developed. Collaborative projects is something that work like this really needs. So there are a lot of people, from computer science that have the programming skills that say, I'm going to go to a hackathon and I'm going to build this tool. But there's no one who wants to use it, and there's no real use case for it. Right? So no one ends up actually doing anything with that. So there needs to be the collaboration with the actual agencies to say, there's something that they can do as a result of your project. And then reusable data and software. Obviously, there are a lot of issues with privacy and all that stuff you have to think really carefully about. But making those decisions thoughtfully, instead of just saying, there's open or closed data. What parts can we make public, even if it's just the schema, as I said, like a standard format. And then software, making everything open source, transparent, reproducible. So the necessary skills that you need to do a data science for social good project, it differs a little bit from your kind of typical data science industry job. So you need the computer science and programming is kind of a given. You need a little bit of that for actually getting real data that can be very messy into a nice format that you can even put in a database and then be able to use the database once the data is in there. Statistics and machine learning, how do you turn this sort of nebulous thing into something that you can model, and then how do you evaluate how those models are doing rigorously? Social science methods, does your data actually reflect what you're thinking, what you're trying to solve, and how much can it be applied to new use cases that are similar, but in a new city, for example? Experimental design, once you make this model and you want to actually implement it and deploy it, how do you test whether it really works? Obviously, the ethics and legal issues, can't stress that enough. Who does your work affect, and what are the good and bad consequences, and thinking really carefully about that. And then the communication, if you can't communicate with the people who are going to use whatever modeling you do or whatever your project is, it doesn't really matter. Like if they don't understand it to some degree, they're not going to use it. So all of those things are, and if things to at least be aware of, and then if you're sort of lacking in them, going out to get those skills, or knowing that maybe you should be on a team with someone that can sort of fill in the gaps. A couple of things that we have developed at University of Chicago. One thing with LRNG, which makes curricula that are designed to be really engaging and sort of like useful for the real world. So we had made this civic tech. It's called a playlist. It's a bunch of different experiences, which are sort of little lessons to help to just learn how to do a civic tech project. That's all up and polished. It's a little bit on the lower technical end of the scale, so it's doing a lot of stuff in Excel, for example, as opposed to, or LibreOffice, as opposed to, writing code. When you're writing code, so we've taken the curriculum from the Data Science for Social Good Summer Fellowship and lumped it all together, saved it, because we want to be able to make it publicly available for anyone, because we want, we really believe in that idea of sharing open source. So we want to be able to say, this is what we think people should know, this is what we teach, and this is sort of my ask/plug, is for you to go check out this work in progress, see what things you might be able to contribute, things that you would like to see. We really welcome all feedback. So please let me know if there's anything that you think would be useful over the summer and beyond. Would love to collaborate with you. And then this is just sort of another another plug for what Bill had mentioned earlier about the responsible data science, that at least give some thought to all these things. In any data science project, the privacy, if you have individual data, how do you make sure that people can't be re-identified if that is a concern, and security, how are you taking care of your data and maintaining it? Interpretability in machine learning models is sometimes nebulous, but being able to at least explain the process of how your modeling works, and then transparency. We also heard that kind of very scary example of the sentencing algorithm. So how can you make sure that your methods are open so that you can get as much feedback from the rest of the community as possible? And then fairness and ethics. Think about when we're dealing with human data, obviously everyone cares a lot about doing the right thing. So thinking about what if you make a mistake, who does it affect? If you predict things correctly, who does it affect? And what could the possible consequences be? So think about that. And I'll be around for the rest of the session. And get a hold of me if you wanted to discuss any of this stuff further. Thanks.
Great. Thanks so much, Jane. And so that makes the end of the 15 lightning talks from academia, industry, government, and nonprofits. We got all of those in there. Please join me in giving them a round of applause for all of their lightning talks and demos. So the idea for the remainder of the little live stream that we have left in the afternoon is that all of those folks who presented will be around the room. You'll have a chance to interact with them. Before we sign off for the people online, though, we'd like to invite Eddie Fuller from the Department of Homeland Security, Nick Bagley, come on down from Utah, Big Data Utah, and Dave again from Data Science. This is part of our all-star team. Jane already gave the plug for the curriculum topic, but we have on our website as of probably 4 a.m. this morning or so, the beginnings of this curated data. So if you go to bigdatahubs.io, you'll see that we've populated an events page. Other hubs are going to be adding different events. We'll actually have one in about a month in Boulder, Colorado, as part of our West Hub all-hands meeting, where teams will be able to give their first pitches and get feedback from a lot of the mentors from the cloud computing companies and other folks supporting this challenge. So definitely mark that on your calendars. We have a section for partners that details what Waze is offering, and the other industry partners will have their details up there soon. The resources page is right now a catch-all for different data sets, but it's essentially tags so you can cross-reference by data set, app, tool, mentor, as well as thematic area. But the topics that we wanted to overview just before we sign off are here. So from bike and pedestrian, how might we improve bike and pedestrian safety in our communities? Dave is going to just mention some of the highlights that he found as the first step and is definitely looking for your input on how we might get some good return on investment for the challenge in that area. Dave?
Thanks, Meredith. So with the bicycle data, I think most of us are familiar with a city bike or Nike Bikey Town, or the fact that it's sort of pervasive across cities that these bicycles are available in all the major metropolitan areas. And I think we're also probably familiar that the access to those bicycles is generally, we're discovering, to the people who can probably afford to buy one of these $1,000 bicycles if they really wanted to. So that's this really classic data science problem that requires surfacing all of this data together. From the technology partner standpoint, Satori has an absolutely incredible aggregated feed of all of these bike data things that they could get their hands on that were open. So they're going to be curating that and offering their tech to get more and more data. And then we still need people who can, we need someone to be a program director, hopefully somebody out here to just sort of manage all the demos and information that comes in. And then we'll need expertise partners too, people who know how to do this kind of analysis. So looking forward to finding that out there.
Great. And on the distracted driving, Dan Morgan mentioned this earlier, but this is really a tough one, and we are looking for volunteers actively to help curate valuable data sets here. We have some ideas, but would love some leadership from the community. The city of Las Vegas is represented here. Dan is in the audience, and he has some great leads on that as well. Next up, we don't have images yet for these, but you can see the prompts. Eddie, if you could come up and explain from the DHS perspective what we're looking to help facilitate for the next two topics, that would be great.
Hi, yes, I'm Eddie Fuller, and I'm a AAAS fellow actually in the Science and Technology Directorate at Homeland Security. So we have a number of different components that we service with data analytics support. It's pretty wide-ranging, but in particular in this area, we're interested in the weather and emergency response subset of this. In particular, some of the drought and flood impacts on transportation, hurricane emergency response, as you might guess. Historically, it's been sort of up and down. Tornado response, traffic during fire response, or other disasters within metropolitan and other areas. But in particular, we have a lot of relationships with FEMA as one of our components, through them as well into local and state, local first responder groups. And so we're interested in ways to actually do better predictive analytics for mobilizing first responder groups into different areas. We have a couple of data sets that we've put up there that we are working with actively to do some modeling in those areas. So I'm interested in, I've actually met a lot of you already, trying to find some data sets that might be integrated into that analysis process. We partner with the RISE lab to try to do some, at UC Berkeley, to do some real-time analytics in these situations where we have multi-latency problems that we have to deal with. So I look forward to talking to anybody who's interested in trying to get to know more and more of the actual municipalities that might be doing some of these things already that we don't know about, so that we can see what things work and what don't. Thanks.
Great. Thank you, Eddie. So the last two listed there are, one is a catch-all, essentially looking at multiple data streams, how we might utilize data from different sectors and different sources to capture actionable insights. The thought there was that we were anticipating, by having events in Seattle, the Denver area, Austin, and so forth, that we'd see a lot of attendees from that specific area and be able to hone in on some interesting opportunities to overlay different data sets and increase some insights in those areas. However, last night we met people from South Carolina, from Wyoming, Idaho, California, Oregon, so it's clear that we'll be getting a lot more interstate mixing throughout at least the next few of these events. So we're really excited about that. That just means we have all the more opportunity to share lessons learned and best practices and build up that community looking at multiple data streams. And Jane already went through the curriculum development, and that makes 6. We're open to others, but we wanted to at least start with some that fall under the umbrella of Vision Zero, but provide a little bit more level of resolution deeper in how we might move forward across different sectors. So thank you very much for your attention. We have coffee, we have the demos, we have a governor coming by, and a reception with about 30 more people from the Northwest Institute for Advanced Computing to round out the day. But this is where we all can stand up and wave bye to our live stream folks. And thanks very much so far for all your participation. You should stand up and wave to the live stream folks. They like that. All right. Thanks all. Please help yourself to coffee. It's out there, and the demos will be around the room. Ed just wants to remind everyone, stick around for the governor. We want a full room. She should be here around 4:45, 5 o'clock. Thanks.